Good morning, everyone. So today we're switching it up from our normal package presentations. We're going to start off with tutorials on coordinates and time, and then moving into some how-to sessions. And Bob will be leading this effort. So, also a reminder, I have the signups for the fun activities tonight out there. Last chance to come if you're interested.
Okay, I'll get started. How am I doing on Zoom? Can everybody hear me? Can I get a thumbs up? If you can hear me somewhere in the... There we go. Thank you. I'm going to try to do a little bit of a better job with the people online. On Monday, I gave a session that was somewhat interactive, but I neglected the people online and I answered a lot of questions in person. So I'll see what I can do there to get people online to participate. And I am also going to possibly ask some questions of people online and also ask them to share their screen. So the target audience for today is primarily students with limited experience in these two items: manipulation and transformation of time representation and transforming data between heliophysics coordinate frames or coordinate systems more informally. This is a very difficult presentation to put together. I looked at the survey results that Julie had out there, and the Python experience level is all over the map. So this is sort of like teaching say a German course where I have students who have never spoke German and maybe students that are on their third or fourth course of taking German. And so I've tried to make this so that it's going to be interesting for everybody here in attendance. And I'll tell you about what I want to do to facilitate that. The primary objective is for you to learn about different options for heliophysics problems related to time and coordinate systems. I won't be able to tell you the details of the physics and exactly the meaning of all the terminology, TAI, and the different coordinates frames like GSM, GSE. You'll be just essentially doing operations on those things and experiments on those things and learning how to do them with different Python packages. And so I have two sessions. The first hour, the first 50 minutes today, and then is going to cover time, and then we'll have a break, and then the second 50 minutes is going to cover space. And I've given a set of problems, and as before, when I was doing my other activity on Happy, I like to, it's called, I guess, a flipped classroom, or do things in a little bit of a reverse. I like to have you guys work on problems, generate questions, get an understanding of what you don't understand, and then I present the answers or present my perspective. And I know that might be kind of an unfamiliar way of doing things, and it's awkward for me. I know it's awkward for you, but my experience is that when I survey students or do a quiz, if I just do it just the straight me talking way, maybe 25% of the students get out of it what I wanted to. And if I do it this way, again, it's awkward, but about 75% of the students are saying the things I want them to say at the very end, or at least understanding what I wanted them to understand. All right, so before I have you guys work in groups, I'll just give you an overview of some of the problems. Some of these are really basic, so you can skip them. And some of them are kind of advanced. And I'd like to engage actually some of the PyHC developers to talk about how they would approach that problem. I think it'll be very valuable for some of the students that are starting out with programming to see the thought process of pretty advanced software engineers. Yeah, if you're out there and you have opinions, feel free to chime in at some point. So the first thing with time is just the very basic parsing time. I do that with date time. It's something everybody has to learn. And then I do some formatting. So again, probably most of you guys have done this. I talked to a few students on Monday that were pretty new to Python. So they were asking questions about NumPy and some of the more fundamental operations. And this problem is for them. And I also give sort of an advanced problem. You can skip, but I think it would be useful for discussion. And the question is this: suppose you have there's a standard for time strings. So there's the ISO 8601 standard, which says that you format your time string as like 2001-01-01 or 2000-0101 with no hyphens. And the standard says that all of those things are valid representations. The trick is to parse that string and turn it into something useful, like a date time. And what I've observed out there is that ISO 861 is a complex standard, and not all these packages implement it exactly. And certainly most packages outside of our community don't handle, for example, leap seconds. So if you have a 60th second of the day, most of the things like pandas and NumPy are going to choke, throw an error. And so I have some references here just based on my research on this. But the question is, suppose you were tasked with implementing this ISO 8601 standard so that you could handle everything. How would you approach it? What would you do? How would you handle errors? And so this is, again, a little bit more for the software engineering side of things. And I think package developers will have some interesting opinions that we can all learn from. A very common task is generating a list of timestamps. And so you saw that with PySpeedas. You saw an example of that with SunPy. And so this section is sort of a review of that and sort of a test of your understanding. So I've given examples of generating a list of times. So suppose you want to create some data, and you would say, on a time scale of 1 hour, 1 hour increment, and you want to plot that data. So you're creating like just fake data that you have a time range. And so there's many ways to do that. And so I've given 4 examples here of doing it. One with just plain old date time and time delta, another with pandas, another with NumPy, date time 64. Anybody know why we have date time 64? Yeah, it goes down to nanosecond resolution. Python's date time only goes down to microsecond. And so date time 64 is essentially an integer, right? John could probably help me with this. I think it measures time in integers. And I think you can set what the reference time is. So it's integer nanoseconds since some start time. And so that allows you to have very, very high precision measurements.
It's just, I stopped paying attention to date time 64 when they told us they wouldn't support leap seconds, unless we could tell them every leap second into the future for all eternity.
That's very good to know.
So.
Oh, yes, thanks. No, this is exactly what I want to get out of this. Yeah.
Yeah. So just for the folks online, I stopped paying attention to date time 64 a decade ago when we asked NumPy about leap second support, and they told us they wouldn't support leap seconds unless we could tell them every leap second into the future for all eternity.
Okay.
So at that point, it's like, well, date time's good enough.
Okay. And then I have another example of doing it. NumPy, I'm sorry, NumPy I already mentioned. And then we have SpacePy, tick range, which you learned a little bit about yesterday, I believe. And so the example here is do it another way. Do it with, my recommendation is to do it with SunPy. There was an example of doing it with that. Actually, SunPy or AstroPy, I think it was AstroPy. So look back at the notebook from the SunPy presentation, which discusses this. And I believe I have a link in here. And so what I want you to do is base that example on generating that time there. And then I also want to start a discussion of why one approach is better than the other. What are you going to choose? And this is something you encounter all the time when you're using these libraries, is you have to think about the implications of your choice, because a year later you might realize, well, like what John said, if you decide to get married to date time 64, and then somebody says, oh, you got to handle leap seconds, suddenly you have this whole infrastructure that handles date time 64, but not leap seconds. And so you have to start back from the beginning. All right, so transforming time. And this is probably where I'll need a little bit of help from some of the people that are more familiar with this, in particular John and I think Neville for the space, one of the SunPy people was here. we were given two examples of doing time transformations, and I've repeated them here. With AstroPy, you import this time object, and you pass it a time string. And AstroPy has this concept of time scales, essentially the length of things, and also a time format, which is how you represent the quantity. So a time format could be isotime, which is a string, could be Julian dates, which is a fractional number, and there are a whole bunch of other formats. And essentially, some of this was new to me, and the first thing I did was try to look at everything. And so this little piece of code here, it says AstroPy supports different formats and different time scales. And so I said, given this UTC time, what is its value in this scale, with this scale, and in this format? So I just generated a table, and that code generates everything. All right, and so one of the things when I'm working with a package myself, or when I'm having a student work on a project, one of the things I have them do is trust but verify. And so if they come to me and they say, I use this package to do this calculation, I would know that if I did that and just got a number, there's probably like a 20% chance that I did something wrong. And so the first thing I always do is look for a way to, one, test my understanding of the documentation, and two, check the actual library to see if it's doing the right thing. And so these are two experiments that I did, and I'd like you guys to give it a try. They're not that difficult, but there's first this claim that epoch J2000, which is defined to be January 1st, 2000 at noon terrestrial time, corresponds to these values in the different scales, TEI, UTC, and here I've mixed into two different formats. Here I'm using the isotime format, and here I'm using the fractional format for Julian time. And so you should have enough information based on the example that I gave and also the presentation on SunPy to answer this question. And then here's another thing. We can test Wikipedia to see if it's correct. SunPy documentation linked to Wikipedia for some of these definitions. And so the first experiment I did was to do this. All right, and then finally I have a SpacePy example, and this one's pretty advanced. So for people that are doing SpacePy, I'd like to see your answers on this. SpacePy has also a set of different systems, systems of time, as they call it. In the AstroPy world, they would call them scales. Most of these they would call scales. And John gave an example of converting to and from the SpacePy representation, which was a tick-tock is the wrapper for time. It's a time object that's used. Converting that between that representation and the AstroPy. And so this exercise is for people that are pretty advanced. And then I have, finally, the last thing I'll mention is plotting. I hate that I have to put this in here, and this is mostly for introductory students, and also kind of for myself, because I find myself having to look this stuff up all the time. The problem is the default tick labels for matplotlib usually require manual modification. So if you're brand new to this kind of stuff, it'd probably help you to work through these examples. It's a constant pain. I'll show you why it's a pain. Let me run this. I would argue that matplotlib is broken if it produces by default a plot with labels that are overlapping. So it's just something you have to deal with. And there's different tricks for dealing with this, but I don't want to spend too much time on this. All right, so those are that's an overview of the different tasks you can work on. And I'll give you guys about 25 minutes to work on these. And then I'm going to circulate, answer questions, and then put some of you on the spot and ask you to share your screen on Zoom. And I'd also like to get at least one question on Zoom that we can answer. So if you're on Zoom, please feel free to participate. And away we go. All right, go to work. Just to clarify, in this time section, if you look for the yellow highlighted sections, there are different problems. Some of them are really easy. If you just kind of know them and exactly know how to do them, skip them. Otherwise, just pick problems that you want to work on and ask questions about them. There's not enough time probably for people to work through all of them. And some of them are fairly advanced. I'm going to interrupt you guys for a few minutes here, talk about some of the things that came up. No questions on Zoom. So if somebody could watch Zoom to see if any questions pop up, that would be helpful. See, Raven and Vicky, which problem did you solve? This one? This one here. Oh, 3.11. Where is it? Tell me when to stop. This one? Okay. All right, could you share your screen? Oh, yeah, Mike.
All right, so we tried problem 3.11, which feeds in a date input like this here, and then asks us to change it up for the output. So we had to confirm that the input was reading it correctly. And then we went and looked up other types of data formats and found STRF time. And that looked like something that could take a time object and change it to whatever format we wanted. So since we wanted 01/02/2008 at 205635.45 some numbers, we looked that up and figured out month, day, year at hour, minute, second.f.
Very good. And you also had something saying like Wednesday, like the day and time. I guess you were playing with those other codes, right? Format codes.
Yeah, the original example we used could also print out the day of the day name, the month name,
Okay.
and similar things.
Good. And actually, can I get a Control plus or 2? I'll keep your screen going here. There we go. I do want to comment on this time, 2008-002. I mentioned that when you pass that to pandas, it wasn't able to parse that. So if you scroll up to, I think where I describe this, where I say pandas fails, if you scroll down, I better take over. So thank you. Share. Oh, I don't think I set it at this point yet. So you have two things with time. You have parsing, and ideally you would just be able to pass an arbitrary string to a parser and say this is an ISO 8601 formatted string, turn it into a date time. As I said, not everybody implements that. And so pandas, if you just pass it a valid string of the form of what you had, which was year, day of year, and you don't tell it what the format is, it's not able to figure it out, even though it's a valid ISO time. And so oftentimes when you're parsing times, you'll have to give the parser a little bit of help and tell it how to whack that string up. And if you're doing date labels and that sort of thing for plotting, you are also going to have to use the time formatting. And so those are just two basic things that you do. Right. And then here I have this simple example here. This is the solution where you do string format time, you give it a month, day, a new line, and then a year. And I sometimes use that trick in plotting because you have date labels, and sometimes you want the hour and then the year below it. Okay, so questions on that? Somebody had thought about this question about writing a function that takes an input of ISO 8601 formatted time string and produces that output. So you're given that task to deal with the fact that not all of these libraries handle it, arbitrary strings. How would you approach it? So John, what was the discussion I think you had with a student? Can you remind me of what that was? And I'd like to hear your suggestion too, since you've dealt with this a lot.
Just sort of all of the ways to deal with ISO 8601.
Yeah.
Yeah, and first off, of course, is if you looked at that Wikipedia page, ISO 8601 is not a single format. It's about 6 zillion formats. So there is actually, so obviously there's STRP time. If you want to use the standard library and be very, very specific. There's also I'm going to get the name wrong, but it's parse ISO or something like that in the standard library now, which it has some flexibility to just kind of throw something at it. So that's pretty good if it's reasonably well formatted. If you have, I have no idea what format this might be. Date util that parser is really nice. Like if you throw something at date util parser, it will almost always extract a date time. It may not be the date time you expect, but it will extract something from it. And so that's ultimate. I'm going to speak to SpacePy because I don't know what the others do, but ultimately SpacePy, we use those as our workhorses and try to find, based on the user's input, which of those makes sense in any given situation. So I think that's kind of the bottom line, is if you're dealing with one of these higher level things like AstroPy time, SpacePy time, hopefully it helps you out on that. If you're wanting to deal with the lower level, then you kind of have to go through the toolkit.
Okay.
See what you can get.
Great, thank you. And I've given a list of links here, and I probably have a few links based on what John just said. The best thing I found dealing with ISO 8601 is this. It's called C ISO 8601. It wraps a very fast C program for parsing time strings. So if you have a lot of them, you want it to be fast, Python's going to be slow. This thing hooks into a C library. And I think AstroPy also has an option to use a C library that parses these times. So I guess my short answer to this question is, how would I approach the problem? I would resist the temptation of trying to solve it myself because nobody's done it right. And I don't think I'm going to be able to, even on my best, most confident days. What I would do is I would set up a whole suite of test problems. And actually, I wouldn't even do that. I would look at all of the unit tests that everybody else has done, combine them into one, all of the ISO 8601 unit tests, combine them into one, and figure out which libraries almost have it correct. And again, if you want to be a lazy programmer, you find a program that gets things almost correct, like Pandas, doesn't handle year, day of year. Otherwise, it's pretty close. I would probably think about contributing to the Pandas library, right? Because then I don't have to maintain my own library. Everybody has access to it, and I can benefit from the knowledge of all of these other people. So those are just some opinions on development. You got to resist the temptation to try and parse it yourself. I think one student said, you know, they looked at the string and they said, okay, we'll try and split it on the hyphens. And then if there's no hyphens, then you can grab the first 4 characters, the second 4 characters, and so on. And you could write, you know, maybe 10 or 20 lines of code. You'll get pretty far pretty quickly, but then the next 50% of the problem is going to take you 10 years. Julie has a comment about the break. Okay, I'll transition there in 1 second. So we have a break coming up in 30 seconds. And my closing remarks, I guess I'll close this off in the next activity, which is that we're going to cover is the space transformations. And so we're going to do something similar with SpacePy and SunPy. And that'll also involve time. So if you taking a break and want to work ahead, you can have a look at those. Julie.
Yeah, okay, so we're on break until 10:05, a shorter one. But before we do that, Peter had a quick comment he wanted to make regarding HelioCloud.
Hey, so I heard this come up a couple times, and I think some people have figured this out already as well. But just want to let everybody know that as they're going through and running all these notebooks, each notebook that you run spins up a separate process, and every time you run a new one, it'll leave those ones lingering, and the memory might fill up. I've been monitoring. I don't think anybody's run into this issue yet, but if you're going through running every single notebook every day, you might be getting close to the 12 gigabyte limit. And if that is the case, you have to make sure that you clean up all of your kernels, and you can do so by either going to the left side here. You see this little, if you hover, it says running terminals and kernels. Just from this last activity, we only have one running right now, and it's not taking up that much memory if you see in the bottom. Or you can also hover here in the bottom, and you can see we have one kernel running. But yeah, just want to let everybody know that if you start to see your memory usage getting high, you can't shut them down. It's not an issue if it does get high, unless like if you want to keep all of them running, that's okay. But if you notice like it's getting high up there, you can go through and close them all.
That's practical to know.
You mentioned that you were monitoring and you were able to see that if we were running up to 12 megabytes or something, right?
I can just see if people's memory usage is really high.
Oh, okay. We
yeah.
can't see it on our end, like how much we're running up till.
You can, right here in the bottom, you can see this memory
Okay.
here. This is showing, I think, in megabytes,
Oh,
but
sorry. Yes.
once
my
you
bad,
cross 1
gigabytes.
gigabyte, it'll format to gigabytes. But yeah. Okay. But that was it. Let's just turn off. Oh, I see.
All right, shorter break today, but there'll be another 15-minute break after about an hour or so. So we're gonna go ahead and get back to it.
Okay, let me get started. So the next 50 minutes is on space transformations using Heliophysics Python libraries. And I just wanted to comment on, make some comments on those time transformations. I gave quite a few problems. Most of the people, it seems, are kind of new to datetime or are maybe familiar with it, but not so much an expert. And I think my takeaway message from this, I was really worried that it was going to be covering things that were too basic. I think part of the problem is that datetime is difficult, and maybe if I haven't thought about it in 2 months, I would be a beginner. And so for the next iteration of this, I'll probably have a few more details on doing basic operations just with the date times, in addition to extending some of the examples using some of the Python libraries out there. Time is a difficult thing, and we could probably spend half a day learning all the ins and outs of it. So I will post solutions, and you guys will have this as a reference. I tried to put things in here that I encounter whenever I start up, and also graduate students encounter when they come up. And in terms of feedback, if there's anything that you guys, as students want to know from the experts on how to handle, let me know and I'll add it to this activity. So I'm going to talk about space transformations. There are three main approaches that we can take. One is a custom library, SpacePy, SunPy, and there are a couple other Python libraries that I haven't listed that will do transformations of different space physics coordinate systems. So geographic, GSE, GSM, GEI, I think you've heard those coordinate systems all mentioned. Those are primarily magnetospheric coordinate systems. And since I'm magnetosphere, I'll probably be biased towards covering mostly that today. SunPy and AstroPy also cover more heliophysics centered or solar centered coordinate systems as well. I won't have time to cover those. And the other approach is SPICE. Has anybody used SPICE, the SPICE library? Okay. And SPICE is a C library that is intended to be used to do coordinate transformations. And it just turns out that most of the people that work on instrument teams will use this approach. And there are wrappers to the SPICE Fortran library in many different languages. One example is SpiceyPy. So the people that have used SPICE probably have used that before. I won't be covering that. I'll primarily talk about these custom libraries that were built sort of ad hoc. With SPICE, you think about coordinate transformations in a little bit of a different way. You actually give it a configuration file, and then the Fortran library does all of the matrix multiplication internally. And so as a user, you're just specifying that. All right, and then there's also various websites out there that I often refer to double check my answers. The first example I'll give is SpacePy. So all of these different coordinate systems have a time dependency. So you have to know what the time is in order to convert from one coordinate system to the other. Ideally, I'd have the time to explain all of these different coordinate system meanings. And for now, I tried to structure this activity so that you just know that they're different coordinate systems and they're related to each other by some sort of transformation, and you don't need to worry necessarily about the details. So we do the usual, we create a tick-tock object. We pass it a ISO time string, and then we also tell SpacePy that it's an ISO time string to help it out. And then we create an input vector. So here it's 0, 0, 1 as an input vector. SpacePy is polymorphic in the sense that you can give it inputs in various different data structures. So here I'm just giving it a plain old Python list. You can also pass it a NumPy array, for example, and it'll figure out what to do. I'm saying that I want this in the mag coordinate system and that my input is Cartesian. So SpacePy, you can say these list of numbers can be either a Cartesian representation, X, Y, Z, or it could be a spherical representation, so it's R theta phi. And we say we want to do that this input applies to the times, these tick-tock times. And so here, when I print this out, I get a coordinates object, which is fine, but then I get CD mag. Anybody who knows coordinate systems, you know why I did that? I called it mag, CD mag. So the mag coordinate system is a coordinate system where the z-axis is aligned with an idealized version of a dipole magnetic field. And to be more specific, you can say it's a center dipole, which means that that dipole field is a vector that goes through the center of the Earth. And so I think what the developers there are saying is that they would prefer you to use this terminology, or that it's trying to tell you that that's what it's doing, John.
Yeah, I think it's a compatibility thing.
Oh, right, because you use on the back end, you're using
Yeah, it's.
Yeah, I think the upshot is that Meg is not strictly defined, but people kind of expect to use it. So we fall down to CD Meg at that point.
Yeah.
I'll look at the code and I'll put in Slack what actually happens, but.
Yeah, I'm dealing with a project now where when we look at these definitions of these different coordinate systems, if you say mag and you talk to 3 different scientists about what does that mean, you might get 3 different answers that are slightly different. And so we're trying to deal with that, coming up with some standards for expressing these different coordinate systems names with some specificity. But for now, that's just something we have to deal with. And so here I'm giving an example of transforming multiple vectors at multiple times. With SpacePy, my understanding is that even if you want to transform a single vector at multiple times, I believe you have to attach a timestamp to the vector that's repeated. And so that's what I'm doing here. It might be tempted to do this all in a loop. Of course, you want to avoid that whenever possible. And so SpacePy happens to allow you to pass essentially a matrix, which is just a whole bunch of vectors that you want to transform. And then your tick-tock object has to have the same number of timestamps. And then you do some sort of conversion here and you get a coordinates object back. I've also done some examples in SunPy, and they use long names for coordinate frame names. And this is because on the back end, I believe they're using AstroPy, which follows that convention. And so here I have a table that lists a mapping from these different coordinate system frames. And as you can guess, I like to do, as you might guess, I try to do things in 2 different ways, trust but verify. And so this is an example of doing a transformation with SunPy, primarily based on the documentation. And so to do that, I'm sorry, I'm doing it with AstroPy. I'm mixing the two up here. Apologies for that. With AstroPy, you create an object, a coordinates object, and you have to pass it a whole bunch of keyword objects. So just like SpacePy, you have a representation type, which can be Cartesian or I believe spherical. You have a timestamp associated with that. And then it uses a frame, which is informally the name of the coordinate system. And then you have some XYZ points. Now AstroPy uses units. And so we need to attach units to the vector. Unfortunately, you can't, in AstroPy, you can't say I have a dimensionless vector, do a transformation. And so the way they do it in the documentation is this. And I'm going to do, in order to simulate doing something dimensionless, I'm just going to attach this R sub E and then divide through it at the very end. I found an interesting issue with this is that initially I used, instead of R sub E, I used 1 meter just to attach a unit. And it turns out that there was some sort of error in a very, very specific transformation. So that was kind of an interesting thing. And again, the reason I tell you that it motivates the trust plus verify thing is most of the time these things are implemented correctly, but you know, that 1% of the time you got to watch out for. And so it's very useful to come up with these validation experiments when you start out. All right, and then the general syntax here is you have coordinate in, sky coordinate in, and then here I'm going to convert it to GSM, and I'm telling it I want the representation to be Cartesian, and then I'm divided by R sub E, and so I get a vector out, and that vector matches to a certain number of decimal places what you get with SpacePy. And then here's an example of doing it with multiple times. I've done something kind of funky here, just for fun. I want to transform a vector at more than one time. And so I generated a time list using the SpacePy tick range, even though you can generate a time list with SunPy. I'm not sure why I did that. I think I was just in a little bit of a rush. I wasn't trying to be creative. And then I have a loop here where I'm modifying the keyword argument to sky coordinates to be this observation time, and then doing the transformation like this. And my understanding is that with AstroPy, you can do a transformation. You can transform many vectors at one timestamp, but I think you have to do a loop if you want to do a transformation at many time values. All right, so that's an example. And the problem for today, there's actually just one simple problem. And these problems are somewhat advanced. So if you want to spend the time continuing to work on some of the time problems, feel free. The first problem is a little bit easier. And it's essentially the mag coordinate frame has a z-axis aligned with the dipole approximation of Earth's internal magnetic field. And it varies in time in the geographic frame. Why is that? Yeah. Does it take into account what? No. So the question is the mag coordinate frame has its z-axis aligned with the dipole approximation of Earth's internal magnetic field. And why should that z-axis change position in the geographic frame? No, that's a different frame. It's because yeah. No, sorry. Yeah, it's the drift of the dipole magnetic field. So over a very long time scale, you have Earth's internal magnetic field is slowly changing with time. And so that vector is slowly changing position. I thought I had an image up here, but it wanders. The dipole location wanders with time over a time scale of years. And so there's a group called the IGRF, International Geographic Reference Field Consortium. And what they do is they take measurements from a whole bunch of magnetometers. They subtract out the contribution of the magnetic field from external sources like the magnetosphere, ionosphere currents. And then the remainder is the magnetic field due to Earth's internal field. And they fit that to a spherical harmonic. And then the first order approximation of that is a dipolar field. And so they come up with these coefficients, and these coefficients are released every 5 years. So the change is slow on a slow time scale. So anyway, so that's the physics of it. And here, here's the first example I did to test my understanding of these libraries. I looked at this useful web page, which defines some of these coordinate frames. And I came across this table. It says, this is the position of a center dipole model of the North Pole. This is the position of it in geographic coordinates. And so, as I mentioned, every 5 years, you get an update, and the latitude and longitude of the location of that z-axis in geographic coordinates is slowly changing. And I said, can I reproduce a result, maybe just, I think I just did 1995 in this table using both of the Python libraries there. So that's the first problem. And then, I'm sorry, that's the second problem. Oh, I know why one of your solutions didn't make sense. I was talking about a different problem. Yes, I had mixed up the problems that I was talking about. So I think one of your answers I said was not correct, but it might have been correct because you were answering the first problem. Okay, so the mag coordinate and the geographic coordinate is everything I've just been talking about. It wanders in time over time scales of many, many years. And then another key parameter is the so-called dipole tilt. And so I think somebody over here was answering that that thing rotates in time. And so I guess since you answered that, why do we care about the dipole tilt angle? Why is it important? Yeah. Mm-hmm. Yeah. So all of these coordinate systems, they're defined for a reason. And the reason is that certain phenomena are best organized in that coordinate frame. And so you're talking about magnetosphere-ionosphere coupling. So suppose the solar wind is just presenting a constant magnetic field. Actually, suppose the solar wind is producing a magnetic field that's in the ecliptic plane, right? And then here we have Earth's dipole magnetic field. Now, what matters for solar wind magnetosphere coupling is the vector, the solar wind vector that's primarily parallel to the magnetic dipole. And so you want to know the angle between those two coordinate systems, the one in the solar wind ecliptic plane, and then also this dipolar coordinate system. And there's, and as time goes on, you have Earth's dipole, and then you have rotation that's taking place, right? And so this thing is rotating with time over the course of a day, and then also over the course of a year. And all of those things can lead to interesting phenomenon that are associated with daily variation and also annual and semi-annual variation. And all of it's explained by the fact that we're just rotating this magnetic dipole with respect to vectors that are primarily ordered in the ecliptic plane. All right, so enough of the physics of that, and I'd like to give you some time to solve this problem. And you might want to look back at the time activity, because in this problem, you're going to have to generate a list of times. And in the time activity, I gave examples of generating a whole bunch of date times. All right, so go to work, and we will reconvene in about 20 minutes. Any questions online? Nope. Okay, so we have 10 minutes before the next break. And first thing I want to do is answer a question that came up in chat. So the question that came up in chat was from Caroline, and I can't zoom this, so I'll read it out loud. To how many decibel places do you need the different transformations to match for you to feel confident they're a match? And I want to give you like a virtual fist bump for asking that question, because it's important. The last thing we always worry about is uncertainties. So I will open the floor for anybody to answer that question. Anybody have an opinion? I guess John is laughing. Yeah, who's dealt with these before? Who's dealt with data, coordinate transformations, and uncertainties? I know somebody has. Dean's laughing, so I'm going to call on him. What's that? Yep.
For PySpeed S, if we're within a couple kilometers, we're usually pretty happy.
Okay, so a couple of kilometers for like a spacecraft
Yeah.
position, right? Well, the fact is that when you do these transformations, you will get different answers. And here we're transforming a vector. I think the way that uncertainties are usually reported for transformations is in terms of an angle. So if I do a transformation from this coordinate system to this coordinate system in two different ways, I would look at the angle between the final answer between the two. And if it's below some threshold, we'll call it good enough. And Dean said it depends on what you're doing. So if you're dealing with data, which has a lot of uncertainty, and you're transforming it to one frame to the other, and you're not going to have to worry about the transformations being uncertain to like the third or fourth decimal place because of the uncertainties are just so much larger on everything else you're doing.
Yeah, I think there's two things. One is obviously what do you need for what you're doing? If you're just, did I do it right? I was just double checking, and different libraries will be different to about 1%.
Yeah.
Based on the assumptions. So for instance, different libraries disagree on the radius of the Earth to the order of about 10 kilometers.
Yes, I've noticed
Which
some
is a good
use,
sized mountain.
some use 0.2 or some use 0.0 as the last value for the Earth radius. Yeah, so I hope that answers your question. And I agree that the within 1%, I've done some experiments with in preparation for this, and maybe in anticipation of this question, comparisons of SSC web, which is a web interface that allows you to do transformations and various other things. And the angle between when you do a transformation, the angle uncertainty is on the order of about a half a degree, which can be huge if you're looking at a spacecraft position, right? But if you're just dealing with science data, you probably don't need to worry about it too much. So thank you for that question. I was going to ask, are there any other general questions before I go over solution? There's another question. Oh boy. All right, I got people engaged on Zoom. That was my only goal for today. So let's see, where is the question? Open, yeah. Does these data you are providing are complete? I think you're asking about the solutions, is that right? Could you clarify that question? I'll come back to it. All right, Dean, could you share your screen for your solution? And he's got a microphone.
Okay, can everyone hear me and see this? Yeah, we can see this. So the problem was to find the dipole angle by comparing what the z-axis is in the MAG coordinate system to what it is in the GSM coordinate system. And so copied and pasted a lot of the code that Bob had given us. And so I just set up here a year of days. It's actually a year of hours. I went to 1/24 over here to get the variation that we'll see over the course of the day. And then I set up our various z-axes. So just set up a real simple array, the z-axis there.
Could I get a control plus?
Oh,
One more.
okay now. Where are we at there? And now I'm kind of
Yeah, it's,
there.
there we go.
Okay. All right. So as I said up here on the previous line, I set up a year of hours, which is where that 1/24 comes at the end. And then set up my z-axis. So am just 0, 0, 1. And then I need to think about what the z-axis and GSM coordinates is in mag. So that's where you got to do the coordinate transformation. So I set up that Z 0, 0, 1 in GSM and then use the space pi convert thing to get it into mag coordinates. And this is going to do, as Bob's earlier example showed, it's going to do it over all of these times. So I'm going to get it once per hour. And so then I have the GSM z-axis in mag coordinates after that conversion. And now I need to find the angle between the two. Well, the fortunate thing is the dot product between the mag axis and the GSM z-axis is just the third component. So that's what I do. And if you look at these, and this can be a little confusing, is that if I look at these GSSM and mag coordinate vectors, you see a whole bunch of stuff in here. And in fact, if I look at the first 5, you see the first 5 vectors. If you lose this command here, you can find out all the methods that's associated with your variable. If you look down here, there's one that's kind of telling you what it is. It's data. So that's how I knew what to pull out of here. So I took, as you can see here, the z-axis and mag vectors, took the data, then took the second component, or cosigned it, and then plotted it. So
Could you change the time range that you run this just for, say, 2 days?
yeah.
So delta day, yeah, change it to 1997, 01, 03 or something.
Might take a little second to run here. It's not the, oh,
Yeah.
it's better than I thought.
Okay, let's see if that makes sense based on what I was saying before. So this is over the course of 2 days. And this is around the winter solstice, right?
Mhm.
And so you have Earth, the North Pole is pointing away from the sun, and it's rotating around its axis like this. And so you have an angle between the vertical ecliptic plane that's varying between essentially the angle of the geographic and then plus or minus the geographic pole with respect to the z-axis and the mag frame. Okay, and I guess I'll make a comment here. I think I mentioned this the other day, and this is to all people who develop Python libraries. A lot of times they do some great transformations, and then they wrap up their results in some sort of object. And it's sort of like, you buy this candy, I think it's Entenmann's candy that you get sometimes around Christmas, and you get it in a box, wrapping paper and a bow. You take that off, and then it's in another nice box, and then there's more plastic and all that kind of stuff. And you really just want the chocolate. And sometimes when I'm dealing with these libraries, the authors are using their own stuff, and so they'll take that object and pass it to another like plotting function that operates on it. But I tend to have my own workflow, and many of us have our own workflow, and we just want to get to the chocolate and pull it out. And so almost all libraries have a way to do that. So my statement here is in your documentation, make it clear how you rip out that information. Dean showed a good way that I often use. You just type dir on the thing that you want to see what methods are applying here. And then we have all of this that I don't really know what's going on. And then there was data, and you can get the X, Y, and Z value and various other things out of there. And so most of those tools that you have, you can do that Duran, and you can also do tab completion. And if you're using an IDE, it'll usually come up. Okay, one other thing I want to mention, a mistake that I made, scroll up a little bit to delta days and maybe scroll over. When I first was using this, I saw delta days and I said, I assumed that delta days meant, and it said something about fractional, it can be a fractional number. And I thought, oh, that's terrible, right? Because you always want to use integers. But I realized later, looking at actually talking to John, he told me that delta days can also be a date time. Excuse me, date time time delta. So you can do time delta hours equal to 24, and that's a little bit nicer in terms of the fact that you're dealing with an integer. So the lesson is I need to be a little bit better at reading documentation. And I guess maybe John was talking about documentation earlier. The thing you have to remember, and I realize that's with some of my packages, is most people just look at the examples. And so I looked at your examples and they just had delta days equal to 1. And then I saw something about fractional and I thought, okay, that's all it does. But I just needed to look up into the doc string and I would have seen it. So examples are important. People cut and paste. And I guess ChatGPT operates generally on examples. So keep that in mind. One thing with your solution that was a little bit I'm a little bit uncertain about. And unfortunately, I lost my solution. I have a partial solution. I'll post a full solution later. The fact that things were truncated around 0 when you plotted over the full time range. Yeah, instead of going, it should go plus or minus because depending on the day of year, right? Because you have in one case you're like this, in another case, so it should be symmetric about 0. And so I'm not sure what happened there with that truncation when you plotted it over the course of, so maybe change this over the course of the year. So, oh, yeah, certainly for the tangent, that would be the case. Well, I'll leave it to Dean to look at that and I'll post the answer later. Yeah. Okay, I think we are, how are we doing on time? Time to break? Time to break? All right, I'll just give you a preview of the next session where it's going to be very different than all of these sessions. And essentially, we're going to talk about collaboration on Git, building repositories, best practices, and you guys are going to submit some issues. You're going to create a GitHub account if you haven't. How many people don't have a GitHub account? Okay, if you don't have a GitHub account, create one before the next session. You're going to need it. All right. And I shall see you guys in 15 minutes. How many minutes? Julie, why isn't this screen working? Oh, yeah, I think so. Oh, I see something on this screen, but not here. I see the background, so maybe I need to share. Oh, I'm looking at Dean's screen, that's why. No, nope, that didn't work. Oh, it looked like it went to two-screen mode. What did you do? Oh, I must have hit it. Okay. Okay, I'm going to get started. And if I could get maybe Julie or Sean, if you could post something in the chat that says what I'm about to say, which is what I'll be covering is in the Summer School 24 repository. You can find it under the how-to section. And click on the README, and then there's a link that will take you to a Google Docs. If you want to follow along. So Summer School, how to, README, and here we go. Stop it. How do I turn that off? All right, stop highlighting stuff, guys. All right, so this is kind of a different session than what we've been covering thus far. It is based on somewhat of popular demand from the past summer school. And it is a first run, which means that it is somewhat experimental. And when I say that, I guess maybe lower your expectations a little bit, be patient. I've run through this a bunch of times and tested it with different people, but first runs are always first runs. And so the idea here is two things. That we want to learn options for structuring and documenting a small project. On the very first day, somebody asked Alex, who was presenting on GitHub and open source collaboration, they said, when would you start using GitHub? And his answer was, start using it right away. And that is an example I'm going to give here is how to do that. And I think everybody has a GitHub account. How many people have GitHub but no repository? Okay, how many people have like 2 or 3 repositories? Okay, so Jim has 100. All right, so some of this will be review for many of you, but I think there'll be stuff that's useful for everybody here. And then the other thing is we're going to learn some basic tools and processes for open source collaboration, in particular, submitting an issue. How many people have ever submitted an issue? All right. And then how many people have submitted a pull request? Oh, wow, quite a few people. Okay, well, this will be somewhat of a review for you guys, and feel free to help out answering questions online or to people just walking around as we do this. So we have a GitHub account, and you guys have already formed groups, so we don't need to do that. And the first thing I'm going to do is give an example of a repository for a small project. I was really tempted to show you guys how to create a Python package, But really what I wanted to do is outline some best practices for creating a project where you're just going to do something, run an experiment, and possibly share with a couple of colleagues or two. And everything I've done here is stuff that I've thought over the past 5 or 10 years when I'm working with students, and I'll work with an undergraduate or a graduate, and I'll give them sort of an entry-level problem to do some sort of analysis, and they'll meet with me once a week. And what I everything I put into here is stuff that I tell them I want to do. And so the nice thing about giving this presentation is it forced me to document what I tell them to do informally. And then again, we have many advanced users, and I'd like some feedback to think, best practices from your perspective. And so when I say a simple project, it only requires a small script. The project the project that I have here is just has a few scripts, so I haven't made it into a package. As soon as you start having to do imports, it's really tempting to do imports in kind of an ad hoc way by modifying the Python path. As soon as you start doing that, resist the temptation. I've done it a bunch of times because you're going to regret it. Learn how to create a package, because Python with imports and all that kind of stuff, it works very nicely and naturally with packages, and modifying the Python path leads to unexpected results. All right, and then I also make some comments on Jupyter Notebooks. My perspective is, if you're doing anything more than a few pages, I would shy away from a Jupyter Notebook. And part of the problem is you can't run it from the command line. It's kind of more difficult to test because you have to open a browser, and there's just more dependencies. And so I generally do things almost exclusively outside of a Jupyter Notebook unless I'm giving a demonstration. All right, and so the general principles that you should have in the README state what it does, and importantly, what it does not do if applicable. So the repositories that I really like to see are the ones where you say, we do this kinds of analysis, we don't do this, and here's some related packages. It's sort of like writing a scientific paper, right? In your introduction, you say, here's the history, here's the state of the art, here's what's missing, and here's what I did, and here is how it's related to the state of the art. And so it's much like writing a paper in that sense. Give links to repositories and other code bases. I think it's important, and I always try to force myself to do this, state why you didn't use another package, right? Because a lot of times you'll come to it and you'll think, well, why did you make this choice? And sometimes it's because you did some speed test, and maybe you're doing MHD simulation analysis, and the transformation or whatever it is just took too much time. And it's useful to document that kind of thing. Another thing that I often run into is structure your code so the plot modifications don't require rerunning the code. So quite often I'll do this myself too. You'll do the analysis, and then you'll have the plot, and then you say, well, I want to change. I just want to tailor the plot, and matplotlib, it takes forever to do that. And usually you just rerun one script over and over, and then you say, well, let me modify the run so that it's at higher precision, and now you're waiting 1 minute to test like a label change. And so just from the very outset, try to separate those two things out, plotting and so on. And the example I do here is I just have a main.py that does the calculations, and then a plot.py that does the plotting. And here I'm going to give you some advice about repositories that you don't want to necessarily follow if you're creating a package. So here I'm saying you're using a repository as sort of a lab notebook. And a lab notebook, you should include lots of information that you're going to need. And so I tend to keep things like plots, like PNG plots, binary files in the repository. And if you're creating a software package, you typically don't want to do that, because Git and these source code management systems, they're mostly for text, looking at differences in text. And so you're uploading binary, you're kind of not using the system for what it's intended to. But here, I like to just have everything in one place. And usually, once that code gets well developed, then I'll just create another project and do things the right way, and then have all of the binary and documentation in a separate place. But again, this is just sort of an entry-level thing that could evolve into a package. All right, and so let me go to that simple project. Oh, and I should also make a little advertisement here. Sean has developed the next natural step to what I'm covering here today is how to create a PyHC package, something that can be pip installable. And so he's created a skeleton project that's linked to there. So if you ever want to create a package that you can share with pip, you can use that to follow. Anonymous Shrew is copying and pasting. Oh, buffalo, rabbit, Sean. So it's popular, Sean. 3 animals looked at it. All right. Now let me go to the project. Oh boy. Oh, I have the wrong link in the code. So let me, or in that document. You don't necessarily need this link right away, but I'm going to put it in the Zoom, somewhere in the Zoom chat. This is the correct link to that repository. Okay, so the first thing that I'm going to do is have somebody, actually, let me get oriented here. I'm a little, got myself turned around. So I talked about the repository structure, and what I'd like to do next is to just discuss what this project does. The entry-level project I typically give is, I say, trace magnetic field lines, because it requires using things that usually are covered in introductory computational physics courses. And it can start it's useful for starting a discussion of magnetic fields and things that we think about in magnetospheric physics. And so one thing I always emphasize is when you read me, I do myself a favor because I always want to be able to copy and paste something and run the code and have it work. And a lot of times people will be tempted to say, okay, do this, modify this variable, execute here. And the likelihood of somebody following that approach is 0, the more complicated you get. And so here I'm giving an example of documenting things. I'm giving an overview of what it does. What this code does is traces a dipole field and then says, I have a starting point near the surface of the Earth. I trace along a dipole field line, and I use 2 different integration algorithms, Runge-Kutta 2.3 and Runge-Kutta 4.5. And the reason I do that is that there's numerical uncertainty associated with that. And so a very good type of uncertainty analysis is just to ask, can I get away with using a coarser integration and get about an answer that's close enough? Because when you're doing these simulations, if you know, both solar and magnetospheric, you typically want to trace thousands and thousands of field lines, and that can be computationally expensive. And so that's the motivation of that problem. And then I have a function generate that also that actually generates those field lines. And so let me just show you how I structure this code. Do a couple control pluses. A habit I've gotten into is copying and pasting a code like this. And what it does is when I execute the code, it prints out what it's doing to the command line, and it also saves what it printed out to the command line to a file. And the reason I do that is I want to come back to this repository, and I might be using an iPad or something without Python, and I can just simply look at the output results, which for some reason I didn't upload here. Sorry about that. And so this is a good template for doing that using the Python logging utility. Here's dipole field. And again, include references. You'll thank yourself later, because a lot of times you did a lot of research to find certain references. Just drop them in a comment. It's going to be very helpful to you and other readers. Here I'm computing the dipole field, and I don't have a derivation of the dipole field. Usually you're given the dipole field equations in spherical coordinates. And here I just have it in Cartesian, and then I have a reference that does it, but I don't have the derivation. And I've also included in the repository is a PDF. And again, it's storing binary in a repository, something you may or may not want to do. It could be controversial, I guess. And so here I just extracted pages from the PDF so that I can come back to it later and look at it without having to do too much work. All right, so this is the integration algorithm, doing the field line tracing. And actually, probably the most important thing is the testing. How many people, when they do a project, do they include unit tests? Like, who's done unit tests before? Okay. Something you want to get in the habit of doing. And the basic idea with a unit test or just testing in general is I do it for two reasons. One is when I come back to my code or I go to somebody else's code, one of the first things I look at is what are their tests doing? A lot of times their tests will tell you a lot about how to use their program, and it'll also tell you how confident you can be in the results. Because if they've done a whole suite of tests, you can be pretty confident that they're doing things the right way. What's another reason for doing testing, for including tests in your code? What's that? Yeah, what is regression? Oh.
When you make updates to your code and you want to make sure you didn't break something with those updates, you run regression tests, make sure you didn't do that.
Yeah, very good. That it helps. It helps a lot with refactoring. And so a regression is, yeah, when you make an update and you break something. And so here I've done, this isn't a great suite of tests. And so later on, we're going to do pull requests. And so if somebody wants to do some better tests, they can. But essentially what I've done is I said, I know that if I'm on the z-axis, the dipole field should be pointing in this direction exactly. And so I'm testing my function in that way. It should be up, down. And then I think on the left and right, it should be certain values. Now there's kind of an art and a science to tests as well. This thing does a very limited set of tests, and it's quite possible that I could modify my dipole function, still pass all of these tests, but be getting wrong answers elsewhere, right? And so, for example, yeah, I've only tested the values at 2 different points. I should probably do it like a scaling test to make sure that the magnitude of the field is falling off with 1 over r squared. And the idea is you want to come up with a minimal set of tests that covers pretty much anything that can go wrong. And even for this simple kind of project, you think, well, why bother with this test? I kind of know I did it right. I printed out a few values. But again, if you do this long enough, you're going to find that you need to do it, or you're going to be, you'll come to rely on these tests as something that's useful. All right. And so again, I have everything packed into one file. This thing is almost at the point where you would want to switch it into the package. And then finally, I guess, given how advanced many of you are, usually put the options at the top. And my general rule of thumb is that once I have a certain, like 3 or 4 configuration variables up there on the top, it's probably time to start refactoring things, because you get 5 or 10 different things. It's very difficult to follow, and some of the input parameters might depend on other parameters. And so what I generally do when I write code is at the very beginning, when you're fresh, is you clean things up a little bit. You add documentation and that sort of thing. All right, so that's the justification of that simple project. It has some flaws, and the first thing that we're going to do is give an example of how. Let me go back to my example here. I guess it looked like about 1/4 of you guys have ever submitted an issue. Is that correct? How many people have submitted issues? Okay. The thing I want, if you leave this session with anything, it is, don't be afraid to submit an issue report. And I mentioned on Mondays some of the reasons why you want to do it. One is that oftentimes you'll submit an issue and you'll be thankful you did, because maybe in the next release of the software package, somebody fixed it. What's another reason for submitting an issue? Yeah. People are happy to know that people are using their product. Yeah, exactly. Sometimes people write proposals to extend a package, and you can say, well, look at all these issue reports or feature requests, and this is justification for demand.
It's also really awesome when you have a problem, you find somebody else had the same problem.
Yes. Oh, yeah, that's too. Yeah. All right. So let's do an issue here. I'm going to do one on SpacePy. Sure, yeah. Okay, so the two things, the first thing you need to do is see if somebody else made that same complaint. Oftentimes you get duplicate comments here. And so I'm going to submit a documentation issue, and to trace 2D feature request, shock. All right, so the basic workflow is that I'm going to open a new issue. And what they've set up here is a template for suggesting how to submit an issue. And my general rule of thumb is that before I submit an issue, I look at the style that other people follow, or the style that other people use, if there isn't a nice template like this. And they also suggest having a minimal example that reproduces the issue. And so another habit that you want to be into is you have to assume that who's ever looking at your issue report is going to want to be able to reproduce that. And so typically what I'll do is provide excruciating details, almost to the point that they can cut and paste and reproduce it and say, oh yeah, he's right. Because a lot of times people will submit issues, and if they're kind of vague, the assumption is if there's any vagueness and you can't actually follow or reproduce actually what they're saying, you say, oh, it's their problem, my software works just fine. And so you want to be as specific as possible. And so I'll just do documentation. And then the IREM link. All right, and so what I noticed was in their documentation, so they link to the SourceForge, and then they say it was moved. So this is about as easy as you can get as an issue. All right, now I'll ask a SpacePy developer, what he thinks of this issue report? What other kind of details would you want? I provided a link, and I'm essentially saying that your documentation links to the library at SourceForge. That link is probably going to die pretty soon.
Tell me where you found the bad link. That would
Yes.
be great, so I know
Yeah.
what to fix.
See, okay, follow. Oh, yep.
Like that's where it's supposed to go. I just don't know where you
yes.
thought we were
Yeah.
going. Oh, okay, yeah. So that makes sense there, right? That's awesome.
Okay, so again, following the pattern. Oh, nope, I copied the wrong. I don't know, I'll turn around here. So this is SpacePy. I'll turn around.
On that top bar there, you
Yeah.
have homepage, development, search, documentation. That teal bar. There you go. If you click on that, that's the actual link of the page you're on. So what I love about that, Bob, is that, yeah, that information's on the first link you gave, but the second link, if the SourceForge one goes down completely, we still have the information we need.
Oh,
So that's very cool.
yes, that's a great point. Always assume there's going to be link rot and links are going to disappear, right? And so, you try to protect against that because
Yeah, if you want extra credit, you could add a label for documentation there,
Oh,
but
yes.
realistically, oh, maybe you can't.
Yeah, I'm not
I've got to change it. We should be able to let people do that.
Yeah, so a lot of these things you can add a label so that when you look at these lists of issues, you can see which ones are tagged with different types of things. All right, now the next, let's see, we have lunch coming up at noon. Yes.
Do you want us to follow you along or avoid creating multiple issues at the same time, or just kind of watch you through?
Oh, okay. So yeah, what I'm going to have you guys do now for the next 10 minutes is submit an issue to my simple project. There are some flaws to it, and some of those are intentional, some of them are unintentional. And so I want you to submit an issue, and we're going to kind of see the workflow and my thought process when you submit an issue. We saw that, with John and myself trying to come up with a way to make something useful for him. We're going to do the same thing with my simple repository. And then another option is if you've encountered an issue on any Python package that have been discussed over the past 2 days, draft up an issue, and then we'll review it. Maybe I'll have you share the screen. We'll review it, and so you can be a little bit more confident when you submit things. I'll have to admit, I got up this morning and I was like, oh, I should submit a SpacePy issue, and I thought, what happened? I should submit a SpacePy issue, and I thought, well, I'm not feeling so confident about that. And then I talked to John, and he said, we have somebody kind of assigned to be dealing with these user-facing issues like documentation. So please do submit it. And so keep that in mind. People don't mind when you submit an issue. We know that when we develop packages, things aren't perfect, and we like to see users contribute and to get feedback. All right, so next 10 minutes, submit an issue on my project, that simple project, and the link for that is again back here. Sorry for jumping around so much. But it's in the Zoom chat. Yeah. So submit an issue report, find an error, find something that needs improvement, draft it up, and then in 10 minutes, I'm going to look at some contributions and give you some feedback. Oh, yeah, that's fine. Yeah, well, thanks for the contributions. That's fair. We have enough submissions already, and there's some surprises here. Let's look at some of these issues and talk about whether they're useful or not. Field lines show unexpected behavior if the field line length is increased. And so this was submitted by Dean, and I told him to not have a perfect issue request, so these criticisms are intentional. Field line length increased, see main.py line 132. Change this to this. Unusual behavior seen in plot. So good enough? Yeah. Yes, include the plot. Another thing I do is, let's go here. You know when your dog urinates on the floor, and the bad thing is the way you don't want to train your dog is you kind of rub your nose in it. And so I always think of, if I'm telling somebody something, I want to show them exactly where it went wrong, make sure they look at it and think about what they did. So I'm going to click this and then copy this link and see main.py. So line 132, I would do this. And then I would also add some coding here. Some markdown coding, unusual behavior seen in plot. I would include the plot. So we kind of know what happened, right? Is that when you trace a field line for too long, eventually you get towards the origin, and your values change. Your field goes like 1 over r squared, and so you get things whipping around in a circle. And so that's something that's easy to fix. Any other comments on this one? All right. Yes, I like this because this is, I would have done this. In MATLAB, it's always just EPS is some constant. And in Python, you always have to look it up. But let me explain what this issue is. Let's go back to the code. This is kind of a detailed thing. But in my tests, I say as long as you're smaller than 1 e to the minus 15. And he called that a magic number, and I agree. It's arbitrary. And if I was looking at that, I would say, where did that number come from? And essentially, I looked at the numbers and the differences, and I said, well, they all look like they're less than 1 e to the minus 15. And so they're probably correct. That's not really a great way to do that. If you happen to be a computational scientist, you would not pass whoever wrote this, which is me. So where does the number 1 e to the minus 15 come from? Why would I use that? Or who raised the magic number issue? Who was that? That was you. Yeah. Why do you think I chose 1 e to the minus 15? It's pretty small. What? Dean? Oh, yeah, microphone. Oh, well, the question is why did I choose 1 e to the minus 15?
Well, it's pretty close to the machine epsilon.
Yeah, and what does machine epsilon correspond to?
The smallest difference between floating point numbers.
Yeah, machine epsilon is smallest difference between floating point numbers, and for IEEE floating point, it's 2.2 times 10 to the minus 16, right? And so this difference should be really scaled to, say, like 10 epsilon. And that 10, again, is kind of a magic number, right? And so if you're really going to do this right, you would look at how the calculation is done, and you would do a propagation of error. But to get halfway there, I would say, just say 10 epsilon. And then as I'm reading this, they're saying, okay, the calculation should be within that level of tolerance.
Mm-hmm.
Yeah, very good. But you know, the fact is I see this a lot in other people's code. So I thought, well, it's probably okay to do it here. All right, so in terms of an issue report, I guess I kind of diverged a little bit. yeah, the comparison to a magic number. Access. So this is very useful because now I don't have to look it up. I mentioned already that it's not very memorable. And so this is likely to get fixed right away because it's going to take one last step for me to look into. Thank you for that. This looks bad. The fourth test and the actual test do not match. So this statement doesn't match this. Oh yeah, because I have -3 and 3 here. Great catch. All right. All right. Yes. So I've encountered this a few times where I've made an issue report and I've seen other people make issue reports and things get a little bit contentious. It's like writing emails. If you're angry, take a 12-hour break before you hit send. And the general thing I use is when I'm writing this is the facts, just the facts, right? You know, it's just like you're writing a journal article. This happened, I expected this. And avoid as much as possible any contentious behavior. Thank you for that example, Jim. I like this one because he writes a little bit like I do. Again, he says it may be, the documentation may be unclear. So he's not saying it's definitely unclear. It was unclear to them. And so you're hedging a little bit. And following block is included in the install and run. All right, open a terminal and do this. Comment could be interpreted as a Boolean operator. So I don't understand this. Let's see. Oh.
Oh yeah.
Yes.
If you have that command, when I was going through it, I was like, oh, I'll just copy in this whole thing. And I was like, oh, that's some cool, like, if not on Heliocloud.
That's
then I realized that that's a comment after the command.
That's a great point. Yeah, there's two ways of doing it is you could put a double comment. So I would put a comment marker after the if. Yeah, but doing it on another line is great. Wow, you guys have found a lot of good stuff here. Holy smokes. All right, question over here. Oh, and you had a comment, and I forgot already what you said it was going to be.
Well, yeah, I guess I'll mention that in a second, but I was going to say back for the other one that you were just talking about with the comment, instead of having to make it 2 different lines, what you can also do is you can use the backtick from to make it a terminal based response. So it will actually kind of imply that that is something that you run in the terminal and the rest of it is just a normal comment. So backticks are the things that are next to the tilde in the top left of your keyboard. And then the other thing I was mentioning was just remember issues don't always need to be problems or bugs. They can also be requests for things. So let's say you want a new feature, right? If you mention that on your on the repo and other people are upvoting it, then it lets the developers know that this is something that people want to see from your project, and the developers are more likely to work on it.
Okay, and then some other comments here. Oh yeah, I noticed this one too, is and I don't know how to fix this. So if you look at the documentation, in this README, oh. It's a markdown issue, but yeah, this was rendering. So I have an example of executing the code, and I always include an example output because again, if I access this a year later, it's quite likely that I don't have Python installed or I don't feel like installing Python and running it and I want to see what I did. So I always include a couple of images in there. And for some reason, that's not rendering. I will fix that. That was an unintentional error. All right, and then let me close this off by giving you a preview of what comes next. I'm going to have you look at that repository and come up with ideas to contribute to it. And so essentially, you're going to pull down that repository and make some code changes, and then do what's called a pull request, where essentially you say, I've forked your repository, I've added this feature, I want you to pull in that new feature into your main repository. How many people have done that again? I think 1, 2, 3, 4, 5. So very few people have done that before. This is a pretty advanced thing to do. However, it's also something you might even want to do when you're working on a project on your own. And I'll explain why that is in a second. It helps you kind of organize your thoughts on different features that you added if you actually add them via pull request, because if you look at the history, it'll be very clear what pieces you added, when and where. It's something I've just started to begin to do. So let me just, for the people because we have a pretty long lunch, and so before I release you, I want to show you how to do this. The first thing you're going to want to do is to fork this repository. So if I click fork, so go to that repository page, that simple project repository, and in the upper right-hand corner, you'll see a button that says fork. Let me get rid of some of this stuff. And you create a fork. Now, what's going to happen is you will see under your GitHub account, so here I've forked it into a repository named autoplot. And so essentially what it's done is taken that simple project repository, created an exact copy of it, and put it into your GitHub account. All right? So that's the first step of what I want you to do. And then the second step is to actually clone that. And I guess you can do that in a number of ways. I'm going to show you how to do it on Helio Cloud. So I'm going to copy the URL of the forked repository. And I'm going to go back to Helio Cloud. And I'm going to go to find a terminal. Or you can use this git button, or this clone button up here. So I'll do it from a terminal since we've shown you how to do it with that button a few times. I'm going to copy this. So this is my username. The owner of the repository is R. Weigel, and then the forked is a different user named autoplot. And I'm going to do a git clone of this. And what you should see is in the root directory, you should have a directory called simple project. All right. So after lunch, and if you get back early from lunch, propose a feature, fix something. There's a bunch of issues there. Propose a fix to it. And I'll go through the workflow and the thought process of how all of that works. So see.
think this session.
Some of us are planning to go over to the 29th Street Mall, which has a ton of different fast casual food options, and then go sit in Scott Carpenter Park, which is really close to it. If you want to be in on that, come here.
All right, so who contributed this? Maybe you can explain a little bit of the logic. There's maybe some useful software engineering principles here. Yeah, go ahead. Pardon me? Oh, the microphone, yeah.
Okay, so I don't know much about the specifics, but I know that like that check is determining if the namespace of the local file is main, which means that the it'll see it as an entry point. So at the bottom right with the if name equals main, it's like checking the name of the namespace.
Mhm.
And if there's a function called main, then it'll have that be the namespace, and then it just runs a function.
Yeah.
I think that like in some IDEs, it won't let you run things that don't have that with like a run button for laziness. Obviously, you can still run it with Python 3
Mhm.
main.py, but it makes it a little easier to.
Yeah, so maybe it'll be easier to look at your main code, which is, let me look at the full source code. And there must be. Yeah, so his complaint was that I had all of these functions and it wasn't clear what the main entry point was. Like all of the code. I just had a whole bunch of functions, and then at the very bottom was things that got executed. And that's usually how one starts out a Python program. But as you said, a more common idiom is that you wrap everything in a function, right? And then at the very bottom, you say, if name is equal to main, you execute that main function. And so if I execute this from the command line, it'll recognize that you're doing Python main.py, and it'll recognize that you're calling from the command line, and it'll execute main. And this is also done in anticipation of when this would be refactored into a package, because I might want to access and import some of these functions. And if I have a whole bunch of code down here, when I do that import, that code will get executed. And so that's part of the reason why you want to encapsulate some of those functions. And so this is something you usually do once you start getting a little bit longer. And then I like some of these other observations where, do I see the diffs here? You had suggested some things that are a little bit more consistent with Python idioms, is that usually when you have a function that's doing some sort of logging, you want to actually pass that logger there, because somebody else might be using your function and they might have their own logging system and they might be writing their own log files. And so you want to be able to override those. So those are all great contributions. And then, all right, so that's the general workflow. And so I'm going to say thank you very much and merge that request. Well, I'll merge it at some point. Yeah, this one looks a little bit smaller. So here he's used resolves number 4. So we got an advanced user, and I trust him, but I'm going to verify. Yes. So this is a style issue, and looks like I had used if compare methods are identically equal to true. And I guess I do that out of habit, maybe just trying to be more explicit. But I think the Python convention is to not do that. Who committed this? Yes. So what is the reason? What is the motivation for this? All right.
Just code style. It's like
Code
personal
style, okay.
preference, really. Because like in some instances, it's like really, it's a non-issue really. But yeah,
Okay.
just I saw it and I was like, oh, I could commit this.
Yeah, it's a good example. It's a good easy example. Why wouldn't I want to do this? Anybody Yeah.
So sometimes even if things look a little bit prettier by not having as much text, it could be more clear what you're explicitly trying to do by keeping the equal true, especially if you had others that would be equal false, rather than the not. If you do an exclamation point in front of the generate line or whatever, that would be a not true thing. But if some people don't know what that means, it could actually cause some confusion. So it totally is a style thing, but either is definitely a way to approach it. Just depends on what you're trying to get across.
Okay, and another, it's not a risk here, but if somebody wrote generate underscored lines and they made an error, they used the number 1. They wouldn't necessarily know that, you know, they use the wrong type. It doesn't matter. You'll get what the user expected. But sometimes if you want to be very, very strict about typing, then you should be super explicit. Now, the final answer, I think I would look into a Python linter. So how many people have used linters? Okay, so if you use what? Yeah, Flake 8 is a linter, and I'm trying to think of the Spider. Yeah, on Spider, there's a drop-down menu where you can do a code analysis, and it'll tell you if you're not following conventional Python style. And conventional Python style would include like using snake case, you know, underscore variables like this, generate underscore lines. It would probably complain that test is kind of a risky word to use because there are probably functions out there that use that word test. And so I recommend that you guys, you know, as you start collaborating with other people, before you submit a pull request, run it through the linter and, you know, see what kind of suggestions you get. And also look into the documentation for the repository that you're contributing to, because they might say what they want to do. They might say, I use Flake 8 with these settings. Does Flake have a whole bunch of options for, yeah. So there'll be a configuration file for Flake, and it'll say allow certain things, disallow certain things. And when you execute that, it'll just tell you, it'll be kind of doing like a spell or grammar check. It says this line is not conforming, even though it's technically correct. It doesn't conform to expectations. And so that's one thing that you'll want to be familiar with. And again, unfortunately, we're using these this is one of the disadvantages of using this notebook, is that if you have an IDE, use VS Code and used to use Spider, but they all have, you know, hooks into these things that allow you to do that pretty quickly. Okay, that's a great contribution, and I will
Spider's code analysis agrees with this.
oh, it does. Really? So I disagree with Spider's code analysis. Not you, but the Spider, because I want to encourage people. So I guess, all right, let me go to conversation.
Determining if it's true twice. So you're doing, if you decision possess resolve the truth. Yes, you're resolving variable equals true. That's determining if it's true, and then the if statement also determines if that's true.
Oh, yeah. So
if you have it in a fact, it's another here. If you have it over, you can speed it up to do if variable prolong rather than if variable equals true prolong.
what about doing if variable is, so you're saying if variable is true, you know, those words. And I think, yeah, what's that? Oh. Well, that's a really surprising thing. I did not know that you're, yeah. Okay, well, thank you for that. I will make a mental note to deal with this. All right, so let me think. We're at 2 o'clock, so we have about Let me look at the timing here. Yeah, we have 10 minutes. I would like to ask if there are any questions from Zoom. Let's see. None so far? Okay, any questions from here? Yeah.
All right, trying again. So I saw that you made the changes, for example, with the 1E minus 15, and you
Mhm.
did that on the GitHub, and then you did the pull request. So what would you do if you were changing stuff on your, on the Helio cloud and then wanted to use that?
Okay,
as
let's
the
do,
change?
yeah, let's do that change. Thank you for reminding me of that. So let's go to Helio Cloud. I did a so let's do simple project, and let me just see what I did here. So I cloned my fork of that repository, so that's okay. So now let's do things the more realistic way, which is I'm going to make a change to main.py, and let me fix one of these issues. I think this was supposed to be a plus. I will save it. And now I will do a get status. And let me try to close this. And what it shows is that I've made a change to main.py. I will do a get diff, which will show me exactly what changed. And then finally, I will do git commit. And I need to tell it what file to commit. And I'm going to put a message. And the message is going to be, where's that typo? Wrong test. I will say that closes number 3. Yes, I need to follow these instructions. And then finally do a git commit. Yeah. So yeah, I need to start using SSH. So the final step would be to do a git push as I suggested. And the change will then appear in my forked repository. And then from there, I can do a get, I can do a pull request. Let's see, but you have, yeah, yeah, it's going to be a hairball. Yeah, so there's a whole, well, if you have a big enough code project. There's usually just one guy in charge of managing all of these different pull requests because there's going to be a conflict because we made changes to the same line in different pull requests. And so we're going to have to handle that as well. Let's see, but have you used Git from the and push to your own repository from GitHub before? No, you have not? Okay, I'll show you how to do that. So, but you have a Git repository now, and what you need to do is look for setting up a personal access token, and that is the thing that they're looking for here. So when it says, git push, it wants a username, and then it used to be you could just enter a password, but now they want a personal access token. It's a little bit of a higher security thing, and it's pretty easy to get, and you just got to find it. Oh yeah, I guess I can show you here. Let's go to so just maybe direct me to that. It would be under the account settings. Yeah. So there under settings, and then it would be which yeah. So you could do add a passkey, and it's going to have me do this whole rigmarole. So I have an assignment, one for myself. Somebody said just use SSH, and I've been saying that to myself for years. I always do things over HTTPS. So I need to figure out how to do that and start using it. And two, look into personal access tokens and just how do you interface with GitHub from the command line. And it should just take a few minutes for you to be able to push and pull. I also tend to use Git command line commands. If I just have a few changes, I just tend to do it from the command line. But there's also GitHub desktop, I think it's called. And so I recommend that if you're making a lot of changes, even to your own repository, look at using GitHub desktop. It'll be really easy to browse and see the kinds of things that you've changed and it'll be a lot more efficient than doing it just from the command line. Any other words of wisdom on Git that anybody has? People that are more experienced? No? Yes.
VS Code works really well with Git. It's very well integrated, so
Okay.
you don't even need to go as far as getting GitHub desktop if you want like a more UI way of doing this. But
Okay, so yeah, I think my advice is yes, you start using an IDE. Most IDEs have Git integration with it. How many people here use Spider? All right, VS Code, PyCharm. All right, we're all over the map. Anything else? Yeah, power user. Someday I'll learn Vim. Sublime, I guess I used to use, yeah. Well, I used to use Spider a lot, but it just got too frustrating, a little bit too crashy, and VS Code is pretty nice, even though it's a Microsoft product. It has a lot of good integrations with Google Copilot, so I don't have any conclusion from that. So this is it. I guess we are switching to the panel session now, and I'll turn it over to Julie. Thank you.
Thanks, Bob. I'm gonna have just everyone who's presented or, associated with the package, maybe we can come to the front. And I think you have the extra mic, so let's bring that up. We're just gonna go through and, kind of answer the questions that people have upvoted in the poll unit. And because this is FOSS or free and open source software, it could be improved sometimes. So this, I can't get it to sort by biggest number of votes. So I'm just gonna scroll through this and ask everyone as we go.
The big dots, just those are the top ones.
Sorry. Yeah, I can control up to find things if I remembered all 25 questions.
It's not biasing. You want to try?
I can here. For now, can we start with this?
You read it. I didn't have my reading glasses up here.
I don't have my reading glasses.
I don't have mine either. Okay, so the top voted question appears to be, what is the process like for importing from IDL to Python and how the transition could be more efficient? Well, I think maybe I should start since PySpeed-S was adapted from IDL Speed-S. In the beginning, we just sort of translated by hand, and it was slow and inefficient. Lately, we've been having some luck with using ChatGPT to sort of paste things in and say, you know, can you translate this IDL code to Python? And a lot of times it does pretty well. Sometimes it has a tendency, like if you have a routine that's defined in IDL and it's not something that's in, you know, NumPy or something like that, it'll sort of hallucinate, you know, assume you've already written it in Python. So it's not an 100% automated process, but it is very helpful. Who else?
Yeah, I think there's two questions. There's the explicit question of porting the code, which you talked about. There's also the question of, do you have to port the code, or is it really just about what functionality do you have? And if you can avoid porting, it's even better. So tricks like scipy.io will let you read IDL save sets. So if you kind of have reached the point where your IDL code has done what it needs to do and you just need the data out, hey, that lets you go forward. And then there's also PyIDL, which will let you go across. So if you can avoid porting and have some other sort of interface, that really makes life easier.
Just a quick comment on that. One case where you want to actually update is when your IDL code is working perfectly, but nobody's able to maintain it anymore because like people that actually wrote it like just retired or something. So in that case, you still want to have a Python version of it just because in case anything goes wrong, if you cannot fix it, that's just not good to, I mean, still have this package to just for maintaining purpose actually.
Yeah, it's really a question of, do you have live code that's going to keep on going things, or code that's kind of served its purpose and you just need the output?
I think I'll mention that the process of switching to IDL or from IDL to Python after grad school in particular is tough because culturally we have so much pressure to publish on us that like taking an extra few months for a publication so that you can learn Python, which I did a while ago, that can have some adverse consequences. So we really need to have more in our culture to have times like the summer school where we set it aside to learn.
Pass it along.
Yeah, I guess I'll make two comments, both about porting code and then about using IDL code. So I think when it comes to porting code, I it's worth thinking about how these two languages are different, right? You know, it's often you're doing a one-to-one translation from one to the other. There are very different paradigms involved in Python, and the languages have different strengths. It's worth thinking about how to refactor the code that you're developing when you're moving from one language to the other. The other piece about sort of end users, transitioning from IDL to Python, I think it's a hard thing. I would definitely also echo an endorsement for the scipy.io read save is a really nice thing. If you have, like, if your IDL code is producing, let's say if you have a function that's really hard to port or you really don't understand what it's doing, but the output is really important to you, which I think happens to all of us a lot. You can just read in the output of whatever that IDL function is into Python, and then off you go. You can do your plotting or post sort of processing, whatever you need to do. In that same vein, I will plug a small package that I wrote as a grad student. It's called HISSW, and for reasons that aren't that important. But what it basically allows you to do is write your IDL code as a string and then execute that. Like it's a Python package. You write your IDL code as a string in line, and you can do sort of fancy variable substitutions, and then it returns to you the output of that IDL code, and it uses SciPy IO read save underneath the hood and does some kind of ugly things, but basically allows you to execute IDL code within a Python session. So I'll post a link to that in the chat in a bit.
I don't really have too much to add other than on Nick's point, if you are interested in getting more help from this type of stuff, look into research software engineer services at your institution. There might be some. If not, there's probably some coming down the pipeline at some point in time. So just keep an eye out for that. It could be really helpful for budgeting towards those things and actually getting help from more experts on it to help you along.
I just want to bounce off of Will's point there, which is if you can do the piecemeal porting like that, where you call some IDL, it's got two advantages. One is that you're not doing it all at once, of course, but also means you can write your testing in Python. And then you pull the IDL code out, slap new Python code in, and use the same test. You actually did the port right.
Sandy had a point in the chat. There's also demo tutorials for calling IDL from Python and vice versa within Helio Cloud, if and only if you have an IDL license installed. Check science tutorial/IDL. However, in all caps, I prefer the panel tendency to avoid IDL. Any further questions or comments on this before we move on? Okay, this was the next one. How do PyHC packages integrate with or complement other Python scientific libraries, e.g. NumPy, SciPy, Pandas?
These packages, I mean, they're highly independent. We use each other's tools and pieces. I mean, a lot of our core functionality, I call SpacePy to do it. And the other things I'm calling other packages to do. I use Happy extensively. And so the more these packages grow, the more we don't want to reinvent the wheel ourselves, right? And so we want to use what's already developed and works well from others, and then add the stuff that you need for your specific science yourself. So the interconnectivity is only going to grow with these things, because that's the way to get quality results out of this much quicker.
I should also add that it's nice to not tie your code to one particular ecosystem like matplotlib. We make it easy to pull the parts out of your tplot variable, so you could use some other plotter or other analysis tools with them.
I guess, yeah, on the SciPy side, we make as heavy use as possible of matplotlib, NumPy at all. We don't reinvent the wheel. I don't think anywhere we can avoid it. We also make, I think, as Nabil showed on Monday, extensive use of AstroPy. We steal from AstroPy wherever we can. It's like all these concepts like WCS, coordinates, units, blah, blah, blah. Like we're just adding kind of SunPy or solar specific sort of like sprinkles on top, but really it's all AstroPy underneath. And then AstroPy uses all of these fundamental libraries as well. Yep.
I think the one thing we could probably do better, I don't know if other folks had better experiences, sometimes we wind up with fairly generic stuff in our domain specific packages that we probably should be running up to SciPy or NumPy, but it's a little intimidating. So we should probably do a better job of that.
Yeah. On the SunPy side, we do have there's some like pushing back upstream to AstroPy that has happened. But then there's been also cases where we wind up with stuff that's in the package for a long time that is more generic, that just ends up living there because we don't have the time to to upstream it as well. But yeah, I think we should be looking for those opportunities everywhere possible.
Something there? Yeah, I want to add something there. Sean in the back. I want to say that this is one of the reasons why organizing and having packages under an umbrella like PyHC is important from a dependency conflict standpoint, because a lot of us do use the same packages. Like we'll all use NumPy in our code or whatever it is. But then when people are actually out in the wild trying to use your code, say I'm trying to import both like SpacePy and PlasmaPy to pick on the two people I'm looking at. Maybe you've used different versions of NumPy. And now that we're relying on functionality from the same generic like Python package, you need to make sure that the environments they're being used in have the same versions of those things. And you run into ugly dependency conflicts when one package is using a NumPy feature from, version X, and the other packages have not put that in there yet. So it just sort of speaks to the fact that this is a fluid ecosystem, and talking together and coordinating that kind of stuff really helps the fact that we are all integrating with these packages.
If I could amend that from a fluid ecosystem to a plasma ecosystem.
Thank you very much.
You lose mic privileges.
I'm sorry.
Any other comments on this or thoughts? Any follow-up questions from the crowd? That's always allowed. Okay.
So when Komodo was being developed, so Asher Pembroke was the original inventor of this, and he had kind of this dream that we designed it as a core package and then a lot of add-ins. The core package, he had this dream that core would be applicable to lots of things. He actually felt that Komodo core would be just as valuable to the finance world, to oil drilling in Texas, to whatever, right? That the core functionality was useful. Now we haven't broached those areas, of course, but the core stuff is there. It can be applied to other science fields as necessary, because that was part of the design philosophy when we designed the core pieces of it. So
Awesome. I have one request to the speakers. Thanks for pointing this out. Can we all shift this way so that like you're all in the camera? Keep going. Keep going. Just keep going. That's probably good enough.
Yeah, sorry about that. Our camera in the room is on the left side of the room here. So
again.
it's, I was pointing out the camera is only catching this side of the room. So that side is just not visible on Zoom. Whoops.
Huh. That would be too easy. And because this will not let me sort, I'm just gonna willy-nilly go through this. Did we already kind of cover this? Do you have any? Yeah, this seems like a very similar question. So if you have further questions about how to transition from IDL, MATLAB, Fortran, older languages, yeah, just put it in general if you have thoughts. I think 7s for the next highly rated. Okay, cool. This is a good one. How can new contributors get involved with your project as a user or developer? And are there particular areas, for example, documentation, coding, testing, where you're seeking more community participation?
Yes, I think as Dara was saying, like the best thing is try to use it for actually doing work, and then please allocate plenty of time for the fact it probably isn't going to work exactly the way you expect, because some of the best things that you can do is bring a concrete use case and bring real specifics on how it falls down in that use case. And once you're at that point, you might be 90% of the way to actually committing code or documentation anyhow, but really well-defined problems are great.
PlasmaPy, if you go to PlasmaPy's documentation, the sidebar on the left, if you scroll most of the way down, there are links to a contributor guide, which go through the details of like how to do the Git and GitHub thing, like how to write documentation, how to write tests. It's pretty detailed. So that's one thing that we've spent a lot of time on trying to build.
Yeah, if you go to pyspeedas.readthedocs.io, we also have a link to a contribution section. And we named a whole bunch of ways that you can contribute that don't necessarily involve writing code. Ask a question. You know, the developers can get sort of blind spots. You know, we all know how it works. We can't necessarily see it with the eyes of someone who's coming in new. And so that helps us see areas where our documentation needs to be stronger. You know, report bugs, or if you see documentation that's lacking and you have something to contribute there, that is super helpful. Or even if you can translate some of our documentation to some other language that you're fluent in, that would be super helpful. And you know, don't get caught up in imposter syndrome, even if you're relatively a beginner. We evaluate contributions on their merits, not the experience level of the person who's submitting them. So like someone said a few days ago, if you see something, say something.
I have something to add here.
One thing I didn't mention in my talk about making pull requests. Usually you'll want to, if you're going to make a pull request that's anything complicated, more than a few lines of code, you'll want to ask an issue, raise an issue and say, I want to do this in general. Should I do it? And if so, how should I do it? I've had a couple of pull requests to my packages where I feel really guilty because I didn't incorporate them. And the reason is this person didn't know what I had in my head for a refactoring of the code, and it kind of conflicted with that. And so it's important that if you have anything, any contribution that's not non-trivial, communicate with the developers and they will be glad to help.
Yeah, I just want to elaborate on that or extend on that a little bit more. So this is generally the way that open source packages work overall. So this doesn't only apply to PyHC, but just open source packages in general. They tend to have a contribution section in their documentation so that you can know how to contribute. Everything's a community-driven thing. So they all want input from everybody, from all users of all ranges. So don't ever hesitate if you think there is something that you can contribute back. Again, raising new issues, you know, converting or translating documentation for others to use as well. All these are very useful things that everybody would appreciate in all open source communities.
Yeah, and piggybacking off that, it is actually part of the PyHC standards that all PyHC packages include contribution guidelines in their repos. So if you're looking to get involved with contributing to a PyHC package, just go to the root directory of the repo and look for something called contributing. It'll be in all capitals. And just real quick to the question, are there any particular areas where you're seeking more community participation? One thing that's been catching on lately is when you're looking at GitHub issues, you can tag issues. And some of the packages lately have been using this good first issue tag. So if you're coming up to the issues for the first time, you might see a collection of them that have a little label telling you, hey, this would be a good first one to look at if you're new to contributing to open source stuff.
Yeah, on the SunPy side, I think we have all the things that have already been mentioned. So I don't have a ton to add. I mean, we have a contributor guide. We also have a very active, it's like Slack. It's called Matrix, but it's like a chat room where we're all kind of just like hanging out all the time. And I think that's a really good sort of informal way to approach us, or it hopefully is. Yeah, we have, I know, especially I will call out Nabil specifically is very, very good at kind of leading new contributors through, like, especially the pull request process, which can often be not painful, but long and involved depending on the feature that's being added or the bug that's being fixed. And yes, I think the good first issue label is a great one. But I will also say that, like, I think the best contribution is often just an issue, just like communicating with the developers. Like on the Solar side, we have a continuous like presence at conferences, like the SunPy development team does, And what we find is that when we go and talk to people, they tell us all these problems they've been having for months. But there's some like, right, yeah, we have a problem of people sort of communicating that to us via all of these avenues that we have. And, you know, that's a hard problem to solve. And again, it's one that's, I think, pretty ubiquitous probably across all of these packages here and in open source in general.
Just real quick, if you don't get anything out of this other than this one thing, just write issues, like contribute in that way. Anything that you run into as an issue, just post it. Like, don't hesitate.
For first pull requests, often I suggest something that is pretty small and self-contained, like fixing a typo. It's also really helpful to add examples to the documentation, to doc strings. And if you want to be even more ambitious, adding an example notebook, which can then be used for the 2026 PyHC Summer School. Also, thank you all for being wonderful and awesome.
I have one other contribution to this. Again, trying to motivate you guys to submit issues. I know for every issue that gets submitted, there's probably 10 that weren't submitted. One of the reasons why you would want to do this is it actually gets your name out there. So if you're a graduate student and you submit some useful issues or pull requests, you know, someday you're going to be on the job market, and it might be that one of these guys is looking to hire somebody or knows somebody that's looking to hire somebody, and they see your name and say, well, you know, this guy can communicate and it looks like he knows how to code. You know, everybody says they know how to write Python in their CV, but of course, sometimes that means you did 1 week, a 1 week course, and sometimes it did 10 weeks. And so you can distinguish between their capabilities for that reason. So thank you.
I want to bounce off two things. One, as you said, Bob, we're solving technical problems, but there's a relationship aspect to it, right? And that part of that is being here, part of that is opening issues, being in Matrix or Slack. So don't neglect that. The other things we've talked about, opening issues. If you go to a repository on GitHub, there is a way that repository can say how they want you to ask for help. A lot of them will be open an issue. On SpacePy, we're kind of pushing people into discussions to start with, because that's a little bit better for kind of the, I don't know what's going on, please help sort of thing. So do check that out. Certainly if in doubt, just go ahead and open an issue, but if there may be some signposts for what the project thinks is the most beneficial way for you to be asking for help.
Not to beat a dead horse, but just to give you yet another reason why you want to contribute is you make a lot of contributions. There are calls for NASA for PyHC development proposals. You submit a proposal. Guess who's going to be on the review panel? Possibly some of these guys, possibly some of these people that, you know, see your name posting issues and posting contributions. And if I'm reviewing, I'm like, okay, this guy knows how to work with the community, and that's one of the requirements in the call for proposals. And therefore, you're more likely to get a high rating on, you know, the likelihood of succeeding.
All right. Any other thoughts or questions regarding that? Cool. All right.
What are the PyHC developers in general like requirements for user testing in terms of merging pull requests? Because I know some packages you need to have like 2 to 3 users verify some test code in order to merge. Like as a general rule, do you guys use that same kind of philosophy or similar?
Should we just run down the line?
Sure. So for SunPy, we have a pretty extensive set of tests that are run on, you hear people have heard of this as CI, like continuous integration, basically just a set of tests that are automatically kicked off when you open a pull request, you know, before things actually get merged. We have a whole range of tests that are run. So that's like that's a very objective criteria. If the tests don't pass, then often, well, sometimes there are reasons that they don't pass, but you know, that's a very objective kind of criteria. And then usually we have a requirement for 2 approvals on a given pull request. So yeah, there's a lot of, there's a very sort of standardized way of sort of vetting, code contributions that are involved in. We don't want people to sort of worry about like, oh, what if I mess something up? It's like, if something is, if there's a negative consequence of some contribution that you made, it's our fault, right? It's not the person who's contributing. Yeah.
Similar to SunPy, we don't have as many code reviewers, so it's only one approval.
Yeah, on SpacePy, there's the hard technical requirement of if the CI doesn't pass, then it's physically impossible to merge, and also requiring one approval. So that's the coded in hard stuff. And then what goes into that approval is kind of just a lot of things, but the upshot is if there's anything in the pull request that one of the maintainers isn't happy about, we'll talk about it, right? So it might be, hey, you've got this new thing and it doesn't break the tests, but it probably should be tested. Do you want to write the test or should one of us write the test for you and check in? So don't worry about your initial pull request checking all of the boxes perfectly. Like bring to the table what you got, and we'll work with you on that. And that might be one of those things where if one of the developers puts in quite a bit of their own time to make that work and quite a bit of their own contributions, then maybe one of the other developers will review it. So it's a truly independent review. But totally bring in what you got.
Yeah, we also lean pretty heavily on our continuous integration tests on GitHub. And you never know when something might slip through the cracks of your test coverage. So I always do try to eyeball it. You get a sense of what changed. If imagine what that might break if our testing isn't perfect. But yeah, but then generally if it looks legit, it goes in.
All right, and I'm going to be a little bit the exception here. Komodo is a little bit of a younger and smaller project than a lot of these, and so it's 2 people that are in charge of this, right? And so it comes down to Lutz and I will look at it and decide, but we've really designed our package to kind of be in layers. And so if you're touching something that could break all kinds of things, that gets a much more thorough testing. But a lot of our things are a reader for a new model. It's only going to be activated if you're using it for that model, right? And so that gets, it still gets tested, but it's not as risky to the rest of the project going forward. So again, depending on the type of pull request coming in, it gets different layers of scrutiny with that.
Jonathan from PySet, how do you all work?
Similar to one of the packages there was earlier, we have a pretty extensive continuous integration testing suite. So if you make some changes and do a pull request, it'll run through all of our tests that already exist. If you add in new functions or change something, you are encouraged to write, tests that cover the new functionality. Sometimes you don't realize that something's broken until you run the tests. You can run them locally. We have a separate requirements list just for testing. So while you're making changes on your machine, you can run the entire testing suite and see if there's any problems before you open up a pull request to get an idea of what you expect there. And then, yeah, we require one approval from one of the sort of core development team at least. And yeah, always happy to help and offer suggestions when we look through the code. Yeah.
Okay.
So I'm not necessarily maintaining a package here in PyHC, but one other thing that we didn't quite mention, but could be useful for this is what's known as draft pull requests. So GitHub allows this idea of, I'm not quite ready to do the full pull request, but I want to make the developers aware that I am going to be submitting something in the near future. And that definitely gives you the ability to have that conversation directly oriented towards some set of code changes. So that's something that I'm not sure if all you all are using, but would, potentially be an avenue for this as well.
Yeah, I was just gonna echo that and something that John said earlier is that this is a very, almost all of our code contributions, including ones that happen from the development team or the core maintainers, are a very iterative process. So there's a lot of back and forth between, especially when it's sometimes the core maintainers, we like to, nitpick at each other occasionally. But that's right. Yeah, that's right. Yes, yes. But that it's not uncommon for this to take a long time, but we don't want that to be discouraging either. That there are reasons that it takes a long time. We want this to be a collaborative process too, most importantly.
Any further thoughts? Okay, instead of going directly to the next question on the list, one popped up during this, which is interesting. So, what strategies do these dev teams have to handle the fact that they don't necessarily look like the diverse community heliophysics is becoming? i.e., if they want people to be asking questions, what strategies are being used to make it a friendly place to ask questions?
Yeah, that's an incredibly important question. So thank you for that. One of the most important things that we need to do is to build psychological safety into our communities. So psychological safety is the group feeling that we can bring our full and authentic selves into our workspace or space of learning, that we can raise issues, that we can make minor mistakes without fear of retaliation or retribution or bullying. And that's pretty challenging because, like, speaking for plasma physics in particular, the culture is kind of like the solar chromosphere. It's a mess. And it takes a lot of work to change this and like make sure that we bring in psychological safety into things like our code reviews. So yeah, so we've in plasma physics, I've helped organize some workshops on psychological safety. And I'll try to remember I think I invited a few people from PyHC to those.
When's the next one? Do you know?
I don't know. Probably, it's likely to be next year.
If you join our PyHC mailing list, which you can do by going to pyhc.org and then go to contact, I'll probably be sending around when that next one opens up, so you can register for it if you're curious about it.
Also, another plug for USRC related things. We have both a diversity, equity, and inclusion working group that specifically talks about this sort of stuff, as well as a affinity group that just started up about neurodiversity. So if you all are interested in having conversations about this, I would definitely suggest joining. Again, totally free, us-rc.org/join. Yeah, we're happy to have conversations like this and trying to, progress this in not only the heliophysics space, but beyond in all kind of software research, software engineering.
That doesn't coffees also have like a diversion inclusive? Yeah.
Yes, so actually every one of the NASA Drive Science Centers as well also has DEI initiatives. That's coffees, consequences of fields and flows in the interior and exterior of the sun, way too long, but it's coffees, it's fun, yeah. CGS, which I don't remember all the other ones because I'm not the sponsors for these, and SHIELD. All of them are also doing a lot of efforts collaboratively as well to make sure that diversity, equity, inclusion is very much thought about in all aspects of the heliophysics community. So if you're interested in it in the broader sense and not just on the software engineering side of things, that's also a great place to look into things.
So just in terms of like, what are we doing? I've got a few things kind of going from the less positive to the more positive. First off, please call us if we fall down on any of this. Like if people are snarky and comments on pull requests and such, I'm going to throw Julia and Sean under the bus here. If you're not comfortable coming to one of us directly, please go to Julia or Sean, and they can help mediate that as leaders in the community. We all have codes of conduct. That's again kind of the bare minimum, putting a floor in there, but I think just having them and having those, GitHub will put the little note right on the pull request, by the way, hey, there's a code of conduct on this project. And I think that does just help remind us all. There's been this culture in the open source community up until 15 years or so ago of being very cantankerous. I think that's shifting. The Subversion project did a lot of work on that, on changing that. Part of it is the idea of, oh, it's a volunteer effort, nobody owes you anything, which is problematic in and of itself. But I think also part of what we're trying to do is change the idea that it's all a volunteer effort. And at the point where we're starting to go and get funding to develop these projects, we now have a responsibility to the community. And then finally, I'm just looking at where I'm, again, on the funding side, getting funding for students, really looking at how I'm recruiting students and trying to broaden that pool that I'm drawing from. So that's just a few things that are going on.
Can I add something? Could you read the first part of that question? I don't know that it was addressed. It's a difficult thing. I couldn't find it. Yeah.
All good. So what strategies do these dev teams have to handle the fact that they don't necessarily look like the diverse community that Heliophysics is becoming?
Yes. Well, there's two solutions, and I think John just spoke of one. That's the bottom-up approach, right? Just from our level, trying to recognize that, this group of developers doesn't necessarily match the demographics of, for example, everybody in this room. And the second solution, and I would recommend, is the top-down approach. And there is a PyHC program manager, Brian Thomas, right? And different people at NASA, they would like to hear comments like that. And they will address that somehow. Maybe in the call for proposals, the drive centers, I think, explicitly said, we want you guys to have, we want you to address this problem. If you're going to get all of this money for this project, you need to address it. I don't think we have such a mandate in PyHC. And if there's demand for it, for example, by comments like this, I think it'll happen. So that's the more of a top-down approach.
How would we, as we're trying to join you, how would we go about instituting that same things at our universities and our clubs if they've shown hostility to such efforts before? And if they're actively doing so?
There is no easy answer to this. And part of the problem is that this is not just a us thing. This is a very large community thing, a US thing, a national or international thing. I can't answer that question by any means. However, again, these types of working groups and other affinity groups and things that are specifically thinking about these issues and trying to come up with ways is a great way to get involved and help lead that effort, because we're all learning and these things are always changing, but the most we can do is make sure everybody's human. We have to think about humanity when we do any of these things. But yeah, there's no easy solution. So sorry, I can't entirely answer it, but again, just look out for these groups that are specifically working on these sorts of efforts and try to get involved so that we can lead in it.
So in plasma physics overall, one of the efforts that a few of us have been working on for some years now has been to craft a human relations code and bias incident policy rooted in the principles of conflict resolution, mediation, and restorative justice. And restorative justice in particular is a process where it's not so punitive, but the person who caused harm is obligated to do the work to repair the harm that they did. And this is this is going to be like a very long-term process because it requires big shifts into our culture. So, yeah, and I think kind of getting back to the first part of the question, the theory of practice that we've been using in plasma physics is the healthy to innovation framework, which, to give credit to like Kimberly Young-McClear, who's one of the whistleblowers from the Coast Guard Academy. If you've seen the Coast Guard Academy in the news, she's awesome. And then like Royce James also, who's another professor there. And psychological safety is the lowest part of the pyramid. And then once we get a foundation of psychological safety, we can move up to moral courage, and then cultural competence, and then diversity and equity and inclusion. And finally, we get up to mission readiness and innovation. And so this is like a systems approach to DEIA, diversity, equity, inclusion, and accessibility. It's one that an organization, Fusion Energy, Pathways to Fusion, is taking. I'll put a graphic in Slack.
So what I was wondering is, from this workshop and kind of like previous instances of coming around the idea of like this kind of contributing to these open source codes and whatnot, one of the things that I think as a young scientist is very like challenging for me is the idea of having to balance kind of like the pressures, and I think a lot of people already hinted to this, of like having to publish, having to like, advance my career, and also wanting to like take part in kind of like making my code more accessible, making my science more kind of like reproducible. So I was wondering if any of you had tips in terms of kind of like how can you balance those two?
In terms of what you personally can do, one thing I would say is think about your priorities. You are never going to have the time and the energy to do everything that is beneficial. And so if your priority in your career is publication count, and as a result, you publish less open source software, that's a decision you can make about your priorities and your time. I mean, we're gonna, all of us here have made somewhat different decisions on that balance. We're also trying to change the culture such that software is not considered so much a lesser thing. So again, not so much helping in your personal balance, but helping all of us to help change the culture. Please cite your software in your papers, if you can. That will really help with that. And look to, again, if you're relying heavily on your publication count, if you have other people in your community or within your organization who are going down more of this research software engineer track, talk with them because they can potentially help you. They get the benefit of filling out their CV with helping you with your software. So there's some possibilities.
Yeah, I don't have any explicit tips that I can give you like right this moment, but again, I'm gonna plug the USRC one more time, probably a few more times. But this is also one of our missions that we're trying to do. Is I think there is a hard reality, right, that publications are how scientists advance their careers, and software has tended to be at the bottom of this. So things that you might be able to do to help. One is actually, again, join these types of groups that are trying to help with it. Two, look for grants that are actually thinking about this stuff and try to apply for those, because the more you apply for those and the more that those get, get out there and people are aware of them, the more likely other grants are going to start taking note and also thinking about this stuff. Also, it's a little late for this year or this set of decadal surveys, but if this is something that you feel is important in the heliophysics community or in the astro community or whatever, is look for decadal survey stuff and think about writing a white paper or getting on board with white papers that talk about this as well. The USRC does have some resources on how to navigate this idea of becoming a research software engineer more exclusively. So again, I would definitely just go to the main website, and at the top, I believe we have a resources tab. And under there is several of these kind of like things that you can look into, including white papers that talk about this. And definitely talk to your higher ups that this is important to you as well. Like, you know, the more we talk about it, the more likely people are going to listen and do something about it. So
this is a fairly, sorry, one second. This is a fairly specific example, I suppose, but I mean, there is PyHC. So if you're working on developing a package and you want awareness around it, that's part of why we exist, is to help people be aware of what's out there. And I mean, PyHC has been invited to more and more NASA specific things. So like they're aware of us. So if you mention you're a part of PyHC and work with our community, that's going to mean something. So consider joining should you come up with some software that you want to submit, or just come to our meetings and be more involved. And I think it was mentioned earlier that some low-hanging fruit for getting funding, which also increases, you know, awareness of what you're doing and help give more credence to the open source work you're doing, is to apply for those NASA ROSES, specifically proposals. If you Google that, I forget what FDOT it is, but it's one of those. Does anyone remember off the top of their head? I'll try to find it. I'll throw it in the chat. It's open now for the 2024 funding, and I think it's just an open rolling submission. So yeah, maybe it's B. I'll put it in Slack. It's pretty simple to officially join. Get on our mailing list, show up at a telecon. That's kind of all there is to it.
Hi, so sorry if you mentioned this before, but like when you were talking about contributing to PyHC and like writing your own or like fixing code or whatever, like I was particularly interested in like documentation and like having everything like categorized, organized, because I know personally for me and probably for everyone else, like our knowledge is kind of like a collection of things that we kind of run into sometimes, rather than like being able to go and actively search, like know where this thing is, like if we want to look at a certain issue, especially with coding. And so I was wondering if there was an effort to like maybe have someone like expand like documentation, or like if you wanted to help specifically with documentation, I would be interested in that. But I don't know if there's like a, you know, just being able to sort everything in one good like giant area, that would be nice to like search through. So
this may only be kind of tangentially related to what you're asking, but on for the SunPy documentation, we've recently tried to adopt this idea of it's called diataxis, but it's like a framework for organizing your documentation to suit the different needs of the people that are coming to your documentation. So for example, if you're like a brand new user, you know, it can be very overwhelming, like knowing where to start, or like what page do I click on, or like what guide do I go through. And so you have like a tutorial that says new users start here, and it kind of leads you linearly through how to do something with a package. And then there's, you know, if you're a more advanced user and you're looking to do a really specific thing, there's a section for that. And it's a very extremely intentional way of laying out your documentation to suit all those different needs. And so that's something we've tried to apply on the SunPy side, and it's something that's kind of becoming more and more popular throughout the wider scientific Python ecosystem. I don't know how many other PyHC packages have adopted that as well, but I think it's a very difficult thing to wrap your head around. But I think we should be like more intentional in the way we think about how we lay out our documentation for our users. Because it's obviously, if you're someone who's been looking at this stuff for a long time, it's very easy to have blind spots about what's clear and what's not clear. I think having some system for thinking about that is really important.
not to put more work on every developer here, but has PyHC thought about trying to come up with a more coalesced like location for being able to search documents in all the PyHC packages to, you know, think about it in that kind of sense? So it's a little bit easier to find things.
John. How do I find out information about stuff that's in PyHC if I don't know what package it's in?
Where do you? Is this working? Yeah, it is. Repeat the question for me one more time so I can answer it succinctly.
So more or less, I was just saying, is there an effort on the PyHC front to be able to more generally search all the documentation for all the PyHC projects rather than having to go to each individual one to find, you know, something that you would like to do or how to use something?
There's a couple half-baked things, nothing great at the moment. On Friday, I'll be demoing our little LLM-based PyHC chatbot, which can have the documentation in the training data, which is one sort of way around that. But the PyHC gallery right now is a thing that exists, and this is future work to be done, but we are going to be trying to, rather than making that something where people just contribute to it as its own separate entity like it is now, just pull from everyone else's documentation. And so I guess that's the direction we're going with the gallery is probably the shortest answer I can say, but it's not a thing yet.
I'm also wondering, we're almost all using Sphinx. Sphinx has search. Is there some like inter-Sphinx bashed up against the index where we can like try to set something up that would be cross-project search? Let's keep talking about that in Slack because I think that might be an option.
Yeah,
Have
that's
we
a good
answered the
idea.
question at all? Okay.
Sean, throw that in the org committee Slack so we don't forget.
Maybe for next time, maybe you'll be graduated by then, but maybe for the next summer school, we could have student contributed notebooks that demonstrate use cases. I think that'd be very valuable for especially the package developers to see how their things are used in the wild, and also to address some of these things. And how can you contribute? That's a very easy way to contribute.
Actually, Bob, I'm going to jump right off of that because it would be awesome if everybody here would try to make a notebook, maybe in the next year, submit a pull request to the 2024 notebooks repository, and we could have like a student example section in there.
Note to myself to remind people. Any other thoughts on that? There was another related question that popped up, so I want to continue down this line of hitting this up before we move to the next official Slido question, or I guess poll unit. So for students who are just learning to code or just learning Python, are there any mentorship resources that we should look into to gauge the unwritten rules of what is polite, what kinds of commitments might be expected on both the mentors and mentee side?
So Plasma Pi has weekly office hours on most Thursdays at 3 p.m. Eastern, not this week. And anyone here should feel free to stop by and we can talk about like whatever Python, Plasma thing stuff that you'd like to. And in the Plasma Pi Slack channel, at the top, I put a bookmark for a link to set up a meeting with me. And please feel free to use that. It was my pandemic way of saying my office door is always open. So yeah, I'm happy to chat and yeah.
I think it would be great if we could set up a mentorship program. I mean, because like this has been so ridiculously ad hoc, and that kind of gets back to the making the people standing up here look more like the whole community thing, is just giving more organized ways of connecting people to develop. So that would be awesome in your copious spare time.
That sounds good. I'm open for PyHC kind of spearheading an effort of that sort. all the FEPs. We haven't talked about FEPs, but if you want to hear more about those, just ask later. Any other thoughts or comments on this?
This is a little less, again, Python specific, but that intersect training that I mentioned could also be very useful, especially if you're just trying to get the basic idea of like, how would one go about doing open source software development? And you'll get very much hands-on experience and this mentee-mentor sort of thing. And just as a comment for the mentee-mentor relationship, in general, that is a two-way street, right? So the mentee can be the mentor sometimes, the mentor can be the mentee sometimes. So definitely keep that in mind. And, you know, again, just try to make sure that you're open and don't feel discouraged to bring up things thinking that, you know, we all have heard the saying multiple times, there's no such thing as bad questions. There really is not. There's no such thing as bad ideas. Everything can start a discussion that can help both sides of the relationship.
All right. Let's hit live. Well, let's go ahead and move on to the next question that we had in the poll. Best practices for newcomers on leveraging PyHC packages. We've kind of touched on this. Yeah. Any additional thoughts on it? Okay. Oh, this is a good one. What are the difficulties and key points that need to be considered when writing my own space physics method into a Python package?
Again, it's kind of like, we were going over, what does a little GitHub repo include, right? If you're writing something specific for this, include examples, include testing, include kind of a thorough description of what's the background. Why did you do it? What does it do? I mean, the more complete the package is, the more useful it'll be to others when it goes in. So there's lots of little sub add-on package. All of these tools have ways to add on a little extra piece that does something specific. But the more complete your piece is, the more people who will find it and make use of it.
I think things like, I'm going to praise SunPy in particular here for the contributors guide, because when you have a contributors guide, yes, that's about how to contribute to an existing project, but implicit in that is a lot of things on what makes a quality project. You can kind of read those things backwards and think about what that means for what you would want to put into your thing. But like really put it on GitHub and just start working. I like go public early. I think that's really probably the biggest thing is the earlier you go public, the earlier people will find you and the earlier you're going to be able to get help.
Yeah, I think there's kind of two pieces there. I mean, I guess the first thing, if you have some bit of code that you think is more widely useful to the community, yeah, I mean, as a first cut, yeah, put it on GitHub. I would also, depending on the size, it may be worth seeing like, could you contribute it to an existing package, right? There might be already be people who want this functionality, and it's going to be often easier to have that be contributed to an existing package rather than having to sort of maintain your own, in perpetuity. Yeah, and there's a whole lot of other things that go into building your own Python package that I think we sort of have talked about today. But I would say that the first thing, yeah, make it public, and then also think about where could it fit into the existing code bases.
I would suggest if you're putting something on GitHub and there are other people sort of in that space that are developing similar software, invite them to your repository. That gets the word out to them that your package is a thing, and then you might get a lot of good comments on room for improvement or what sort of features other people would like to see in it, and that'll help you make connections in the community.
A common thing we also have for PyHC, if there's a new Python related package and you want to submit it to us, is that we ask that you come and present on your package at one of our telecons. So you're always free to just ping me. It's my first last name at lasp.colorado.edu. And I'm very happy to get people on, especially if they're, newer to PyHC, if they're early career. I'm very gung ho about that. So. And also, if you're trying to make a good package, they've mentioned some good ideas, but there's also the PyHC standards where if you're following those, you're probably doing pretty well as far as making a Python package goes. And you can find those on our website, pyhc.org again, under the documents. Okay. Let's see, we answered the 14s. I'm kind of curious what people have to say to this one. Are there common misconceptions about PyHC or heliophysics software development that you'd like to clarify?
That we never get anything wrong. I mean, we constantly are learning from our own mistakes. So again, just to not put all of us on like pedestals, like we're experts, that we never make mistakes or anything. We're all humans. So there's definitely maybe a misconception that, all this code just works right off the bat or something. But again, we're all making mistakes and iterating off of each other. So.
Yeah, very much in that same vein. On the kind of solar physics side, I think often when we go to conferences, or even people that are our friends who are solar physicists who are not necessarily SunPy developers, I think a lot of people tell me all the time, like, oh, well, my code is not up to like the SunPy standards, whatever. Like there's this kind of constant, I think, perception that because because we apply particular criteria to our package that we're sort of snobs about software more generally. And I guess that maybe that speaks to like a problem sort of culturally, but I think also just we want to not, for people not to think about it that way. That we are very much willing to, our code the first time we write it also very much not perfect, right? Again, this goes back to this idea of like a code contribution is an iterative, collaborative process. Like things are not perfect. The tests don't pass the first time, or rarely pass the first time. So that that we will work with you to such that you meet this criteria that we've laid out.
Just to drive that point further home, that not everyone's perfect. So we have our standards grouped into, I think it's 6 different categories here, and green is if you're doing everything perfectly. And even our core packages don't have fully green. You scroll through our packages and they're at varying levels of, getting really in line with PyHC standards. And that's okay. We can work with you and try to help you to, improve. So even the people up here have not necessarily submitted the world's most perfect package, and that's okay.
I think the flip side of it's not all perfect is also, just because it doesn't work for you doesn't mean it's inherently a piece of crap. It probably worked for somebody, and there's just something different about your use case than the last guy's use case. So if it blows up in horrible smoke and flames, open an issue and we'll figure it out. In fact, the bigger the smoke and flames, usually the simpler the problem.
Just I didn't mention this when I was talking about code reviews, but that this is part of the reason that we do have code reviews, right? It is to make it so that we can catch issues. If everybody was perfect, we wouldn't need them, right? So yeah. So again, we're trying to create these cultures kind of in our methodology and the way that we approach our packages as well. So.
Any other thoughts?
I'll ask the audience. You guys maybe didn't know that much about PyHC before you came to the summer school. Did you have any misconceptions or conceptions that have changed
after being here for 3 days and working with us? You did? What would that be?
Yeah, we need a sponge microphone. Since I have
When I first came here, I was expecting to see a lot more like advanced things that I wouldn't be able to understand. When I came here and went like, oh, this is readable. I can understand this. This is the universal language.
Remember, there's no bad comments.
Okay, let's find the next more highly rated question. That was scrolling too far. Here's a good one. If we enjoyed one specific package, how would we learn more about it after the summer school resources have been expended?
I would say probably the best thing to do is to go to the gallery of example notebooks that most of the packages have. And we have about like 30 on Plasma Pi's documentation site. And those give a good idea of what the people who have contributed to the package think are the cool parts about it.
Sean can put the link in the Slack that I'm about to mention, so you heard. But we're holding on to all these summer school resources as well as the presentations in our GitHub, which is obviously open source. So you can just go right to it and find it and still see all these materials there. HelioCloud instance itself may not be up, but you can still download and use packages if you so choose.
Yeah, I think I linked this during Nabil's talk on Monday, but we have, if you go to docs.sunpi.org, on that landing page, there's a big button that says tutorial for new users, start here. That tutorial covers all the stuff that Nabil talked about on Monday, plus more and a lot more detail. So I would recommend starting there. Yeah, and also, yes, the example gallery is also a great place. So it can be a bit more, here's a bunch of stuff you can do. It's more like if you already know what you're looking for. But I think that the tutorial would be a great place to start and do like a deep dive on all the stuff you can do with SunPy.
I think Alex is trying to find out for us about HelioCloud.
Yeah, so I was just trying to get a bit more information. So this idea of HelioCloud in general, right? More of the cloud data being on the cloud, the resources, the compute resources being right there, the installation of the packages that you need to run things all being in one place, known as HelioCloud, is still a bit in the works. But if you are interested in using it beyond the summer school, I would reach out to Brian Thomas at NASA, who is the lead for HelioCloud. And he should be able to help you get an account if you want to continue doing all your stuff on the cloud.
Also, if you want to get in contact with Brian, we're using a PyHC summer school Slack that's kind of ephemeral and goes away after this. We have a normal PyHC Slack, just pure. You can just Slack me if you want to get added to it. We just don't have an expiring invite on our website to avoid bots just coming and being ridiculous. But he's on there and you can ping him, so.
And I would be remiss if I did not add. So the question again was, if we enjoyed a specific package, how would we learn more about it after the summer school resources are gone? This summer school and HelioCloud and stuff is just something we're doing for this week. We do have a projects page on pyhc.org. So I have in general put a link to it. Is simply, yep, it's right up there on the screen right now. Go to pyhc.org/projects and we link to the GitHub repos, the documentation, and all that stuff. So that's like really how to figure out what's up with the package.
And the name of who to ping for it, which we're still working on adding some contact info in there without doxing everyone's emails. But a lot of these people are on our Slack, so you can also ping them there. Any other thoughts on that point?
I guess I'll also add that there's a contact page in the PyHC website too. So maybe if you could show that just very briefly. That has links to our mailing list, so you can email us, or it even has links to like our Slack and our telecons and stuff like that.
And hey, my email is just directly on that page. Maybe that's why I get so much spam. It's fine. But yeah, always feel free to ping me. Okay, let's hit up the next question. Just seeing if there were any other big ones. You know what? There was one down here that was a 4 that was good. It seems like there's a lot of overlap between some of the libraries in terms of plotting and data retrieval. Is there any advantage, I know, to a particular library, or is it largely just personal preference?
I think in terms of plotting, there's less overlap than it looks like because almost all of us are kind of down to matplotlib at the bottom level. But there's definitely some duplication. A lot of it is, yeah, preference. Which package seems to match the way you think? Which package supports the tools that you need to do your work? We had when we were first in this room 6 years ago, we had a pretty big conversation about, do we try to like make sure there's only one way to do anything? And the conclusion was that probably wasn't going to be practical, but we were still going to try our best to not add more if we could avoid it, and also try to make different ways of doing things work together.
Yeah, I think this is a continual challenge within this community is all the packages that you've seen sort of grew up independently of one another, more or less. And so there are different ways of doing the same thing often. And I think yeah, as John said, it's been a conversation that's been going on for 6 years about how to, I guess, be as interoperable as possible. And I don't think we've found a solution to that problem yet.
I wasn't a part of this effort, not being a package maintainer myself, but at some point there was a data adapters effort to be able to work projects between one another.
Yeah, and unfortunately, a lot of that has landed on me. So that's still, we have some stale pull requests that were tied up by, honestly, just utils going away and all of my SpacePy time going into that. But I have pull requests that need to go into SunPy and stale pull requests into SpacePy from Happy. So yeah, that's still an ongoing thing. And yeah, mea culpa, I guess.
Is that something you could write issues on for people to contribute on to help you do that?
I think at this point, the framing out is pretty well done, and we're kind of into the where do you fit the joins and the grooves together stuff, which is much harder as a starting point. So
I guess I would throw out that I'm actually a proponent of actually having multiple ways to do certain things, because there are subtle differences in the tools. They may look very similar, but there are subtle differences, and sometimes one of them just has a big advantage that may not be apparent, right? And sometimes in the age we're going now, a lot of it has to do with automating things, right? And so I can go to SSC Web and get things with their API. I found I like to use the Happy one because I've already used Happy somewhere else. So using that tool, and it doesn't take anything away from their own internal API because that has a use and a target audience. But multiple ways of doing things can be advantageous to it as well. I don't like putting all my eggs in one basket. And, you know, just to throw the old cliche out there, right? There's multiple ways to do things, and that could be beneficial. I mean, packages that get stale and aren't maintained, yeah, those are ones you gotta prune at some point. But if they're actively developed and supported, then more than one way to do it is not always bad.
I was gonna say, I think as I'm more speaking to everyone up here now, I suppose, that as package developers, we should also be cognizant of the fact that for new users, when there are a variety of ways to do the same thing with seemingly no differences between them, that can be a difficult thing to do, and makes it harder for people to do their work when there are multiple ways to do the same thing. So I think as a community, that's something we should be cognizant of.
Something that can make that worse, but I think we should still do, is where we have places where we know there's overlap, we really should be cross-linking our documentation. Look, we have this thing here, it's in our package, it does this task, but there's this other stuff that might be relevant that you might want to take a look at.
All right. Okay, how are packages vetted and integrated? I'm not sure if this is meant from like an overall PyHC perspective or within. Yeah, that's kind of what I think. So currently, it's not the like highest bar to entry. We have our PyHC standards that you can go and find. Boop. If I didn't have so many tabs open and in the way, but you can go through and see exactly what it is that we ask of your package to have before thinking about, submitting with us or what have you. So you do basically a self-evaluation against those, and those get vetted by Sean currently at the moment. There are plans in the works for having, more thorough reviews of projects go through a different community called PyOpenSci that would add an extra level of credence to your project. But sounds like you want to speak more on it.
Yeah, I'll step into the limelight for just 1 second and say that, hi, I'm Sean Polson, the tech lead of PyHC. I'm the person who does that. So at the moment, the process is pretty much just whatever I want it to be. But what happens is normally when people want to submit a package to PyHC, they just open a PR to our website to add in the metadata to have their package be displayed on our projects page. And I see you quickly going over there. Yeah, so people are opening pull requests via these project edition instructions right there at the very top of the website. And then I go and I review all the PRs, and I basically just look at your repo and ask myself, does this live up to the standards? And we normally ask people in the project edition guidelines to give a sort of self-evaluation of point by point how you think you stack up to the standards. And then I either agree with you or disagree with you. And then there's some kind of back and forth in the pull request. And then for the most part, I've been merging everyone who requests to join. I can only think of one other time where someone was just pretty obviously like not even that much of a Python package. So I rejected them, but I can only think of one time I've done that. So that's pretty much how it works right now.
Yeah, we also, I've mentioned it once before, but have you come and talk on our telecons so people can find out about the package and we can see if there's any, overlap or duplication of efforts happening. Sometimes it's better to submit to something that's already working than create your whole own thing for it. That's all I have to say on that. So if you have more questions, ping me. Let's see. I think that kind of ties into the question below of what quality gates do the packages run through before they're published. So that feels pretty similar. There was a good one down here about RSE. I feel like this is going to be you. So how to navigate working as a research software engineer. You guys can talk from experience. Where do you find these kind of jobs?
All right, so one more plug of the USRSC. Go to us-rsc.org. We have job postings there that pretty much anybody can post their jobs to once you become a member. We also have a very active Slack space that also talks about everything you are RSC related, research software engineering related, but we also have a specific job channel. So there's constantly stuff on there. I actually see a lot from LASP all the time. In terms of actual resources for how to navigate becoming an RSE, a research software engineer, again, that tab that should be on the homepage of the USRSC's website, there is a specific resources section, and there is explicit guides for this stuff. So that would definitely be one of the places you can go and check out information. If you join the USRSC, you can also just start asking people on the Slack space, and you'll definitely get a lot of input from people there as well. So,
in terms of finding the jobs, I think it's important to realize that it's a new term, it's a new role. You're not going to see too many job listings as RSE. This is a little like trying to become a space physicist in 1961, where yes, it's an important thing. There's work to be done, but people don't necessarily notice it. So for instance, my last job title is Research Scientist 3. My current job title is Principal Research Project Manager. So just be aware that you're hoeing a little bit of your own row for the next bit. And that's what USR is really trying to do, is to say, okay, this is a job title, this is a career path, this is something that's not fully established yet.
yeah, actually, I just remembered that I specifically gave a talk about the USRSC and talked on some of these things at the PyHC Telecon. So another reason to join, so that, well, I guess you can get it from YouTube anyway, but there should be a recording of that talk so you can kind of listen to this spiel a little bit more. But yeah, the term just got developed in about 2014. So like in the UK, and it just recently, more so recently, came over here. So it is a really new field. Well, it's a new official-ish field, even though we have been around for forever.
I'm pretty sure what I started as was called a scientific programmer. So you can look for those too.
Yeah, that's good. I'm still just a software developer, not even an engineer.
I was just going to say too, like a lot of these funding calls that have been mentioned, so proposals to do this kind of work allow you to be sort of a research software engineer for at least part of your time. So if you're in a postdoc position, or even sort of these like non-tenured track type positions, like any position where you can PI a proposal or be a co-I on a proposal, that is an avenue that allows you to do this kind of work.
Any other thoughts, follow-up questions?
Also, if you have more questions specifically about this, just reach directly out to me, because I will have the thing shared, right? So my contact information is in the in my presentation.
It was just like a quick side thing, but like when you're like developing a software, like if you're doing this as a job, it's not like just spontaneous creation, like, oh, I just thought of this software and now I'm trying to make it, right? It's usually coming from like an issue that someone else is trying to solve, and then you're kind of parallel developing it while they're, doing their research, right? I just was wondering how that process happens, like how you're developing, a new software.
Yeah, for a lot of us, it's we're trying to solve a problem, and or we're on a team trying to solve a problem, and it's, oh, this is something that we'll probably need to use again. And if we do it really carefully and generically now, that will benefit us a lot. So most of the stuff I've written has come out of either a paper I'm writing or a mission that I'm responsible for delivering data on.
Yeah, I was gonna say, I think this can happen sort of several ways. Like a lot of us up here, it sort of grew out of the research that we were already doing, and that's the software projects that we work on. But there are groups at universities, like research software engineering groups, that are they're scientists that have sort of transitioned to being software engineers, and then they're sort of contracted out to particular research groups, usually within the university, and then they're working on the problems that are specific to that research group. So it's like, I might be a solar physicist by training, but I'm working with like a biomedical imaging group or something, because they have, maybe they have images, and so those sort of look like images of the sun, so that like the skills are transferable, but the software is like completely different. So there are increasingly groups like that as well. Yeah.
Yeah, this kind of goes back to my point that I was making earlier, where I ironically am just considered a software developer, and Stanford does not have official positions for research software engineers, yet we have a research software engineering group on campus. So, and there are people who have, you know, obviously I consider myself a research software engineer. That's what I put as my title, but officially at Stanford, it doesn't exist. But the positions probably still do exist. And these groups that Will was just mentioning are at a lot of universities. If you happen to be at Princeton or work with anybody at Princeton, that's a massive one. You should definitely talk to them because they have a lot of real great experience. But yeah, they're at a lot of institutions now.
All right, we have about 3 minutes before our break / official time to go and see the few posters that we have out in the main lobby. So I'm trying to find if there's a quick question. This one wasn't voted up, but I'm just curious to hear the can of worms that gets blasted open. When are you going to submit all your work to Conda Forge if you're not on it? Who all is on Conda? Who's on? Yeah,
SunPy is.
I think everyone's like on PIP, right?
Should we also say what Conda Forge
Yeah.
is as well? So probably most people are familiar with the Anaconda distribution of Python. It's just a particular Python runtime that's shipped by the company Anaconda. Solved a lot of like annoying packaging issues about 5 or 6 years ago. And so that the company maintains a distribution of Python as well as a bunch of packages, but then there's this been this community effort to package do Python packaging in the same way that the company Anaconda has done, but through a community forum as opposed to the company itself approving all those packages. So this is like an alternative to pip. So if you do pip install, that comes from something called the Python package index. The Conda packages come from another place, and there are advantages and disadvantages for packaging code one way, but they're not mutually exclusive. You can do both, and in fact, we probably should be striving to do both.
Yeah. Also, an important advantage of Conda Forge over Conda is that NASA can actually use it because the licensing on base Anaconda is very restrictive.
Yes, yeah. Recently, there have been some annoying restrictions that because Anaconda or Continuum or whatever, I guess they're called Anaconda now, has applied to like either large companies or large government institutions, which, as you might infer, includes NASA. Universities are.
Yeah, universities are okay.
Yeah, one obstacle to getting on Conda Forge is that your dependencies also have to be on there. And so we have one that I won't name, but they're not on Conda Forge yet. And that one package is kind of a one-man show. So we're not sure when that is going to happen.
I will point out that anyone can put any package on Conda Forge. You do not have to be the author of that library to put something on Conda Forge. But then you're also stuck maintaining that recipe. So
You should probably tell the author if you're going to do that, though. So Brian, there's the answer to your question if you're online. We have less than a minute left before the break, so let's just go to break. We have a break for the next 30 minutes, so we're back at 4:10. We have a couple more questions to wrap up for the panel, and then we'll be free, and you cannot stare at us or the screens anymore. Fun activities all start around 6 p.m., so if you're involved in the axe throwing or escape rooms, just know that. And there are still some spots if you've last minute decided you want to come. Enjoy your break.
or do some math, you can drop the code inline there in the notebook. And if you containerize it and share it, it's like the most reproducible form of publication that exists at the moment, pretty much. PyHC does encourage people to do that. So that's like one big reproducibility hit. And other than that, just generally the fact that we're trying to make our packages more interoperable and work together. I'd be probably hand waving if I tried to go any deeper than that.
Cool. And the last question that I wanted to address, I guess it's two questions. What are the main advantages of leveraging PyHC packages, and what are some of the areas that PyHC is looking to expand and improve on in the following years? So the biggest advantages of leveraging a PyHC package is you have a community that you can speak with. They've at least gone through some initial vetting to even get into our community, so you can trust that they're a legitimate project. And one of the future ways that we're expanding and improving in the following years is combining with this community called PyOpenSci. That is a community of people that literally serve to help you review your code against not only, you know, just their standards, but ours, and then as a community, how well you're following or not our standards. And so it's kind of an extra layer of trustworthiness and proof of robustness of our projects. So that's one thing that we're doing to try and expand in the following years, and would be a good reason to leverage our packages just because, you know, they're trustworthy, they've been vetted, and there's a lot of different capabilities within them.
Maybe like a second. I can't add too much more than that, other than to say the work we have done getting packages to work together in the same Python environment, you know, practically speaking, like for this HelioCloud environment we're using, PyHC packages are more likely to be importable into your workflow than a non-PyHC package, because we actually have humans having conversations working to make that happen. And in the future, obviously, we're going to keep expanding that, but also there are other upcoming positions in PyHC that are not filled yet because we have not started hiring for them, but we're looking to get like an intern and some other things to help with, you know, more of the development side and addressing GitHub issues and these kinds of things. So I think just generally speaking, being in a community like us and having that kind of thing on the future horizon is a way that we're going to be improving that. Yeah, that's it.
Okay, well, those are the last two questions I just wanted to hit up before we leave. So if you're online, thank you. You can go ahead and log off. We're just going to be organizing the in-person activities now. If you had signed up for the escape room, go find Sean, and then we're going to figure out how we want to meet up and so forth. And I'm the axe throwing person, so come to me for that. Thank you. Same time, same place tomorrow.